list and try to make it. And I guess, Vince, our goal here is there's been a lot of changes through the cycles, the last couple cycles when it comes to equipotential bonding. A lot of information has been provided to determine whether or not the old single 8 gauge running around the perimeter is acceptable anymore, or whether or not it's no longer allowed, or if it is allowed, when. So, again, not going to cover really what's in the 2023 edition. We're going to focus on where it is now in the 2026. Although, if we have to jump back and talk about something, we can, but that's what we're going to try to focus. So, you agree? Let's kind of make it so somebody watching this piece of it, and the way it's designed is this is a standalone part, or a subdivision or subpart of the part two, because some people may just want to pull out this equipotential bonding. It may be critical. They may understand other aspects of the code fairly well, but this they don't. So we want to make sure that we do that. So are we ready? We ready to dig into it and see if we can cover it?
Yeah, let's see what kind of damage we.
All right. All right, folks, here we are. We're at 680.26, and we'll be looking at, first thing is 680.26, performance. Okay, so what is the equipotential bonds supposed to do? Okay, what is this function? What is its nature of its intent? And says the equipotential bonding required in 680.26b, which is what we're starting in now, or we're going to be in, and 680.26c, okay, is to reduce voltage gradients in the pool area shall be installed for pools with or without associated electrical equipment related to the pool. So this is going to say that we have to have the equipotential bonding regardless of whether or not we have power to this pool.
That's right.
So, and there might be, one of the examples in a typical pool may not have lighting. The pumps could be somewhere else, but there's really no power coming to the pool. It's the pool itself doesn't have to have lights, right? So we didn't want people to think that, oh, if I don't have any electric running to this pool, that I don't have to meet these bonding requirements.
That's correct. Because you probably have other elements that are down in the list item that we're going to look at that are probably going to be present there. Whether that's, the things will work through metal within 5-foot fence or some, or you have the pool shell, or you have the perimeter surface of the field. So all that has to be looked at. And that's what we'll hopefully not overcomplicate what the requirement.
The voltage gradient, to reduce voltage gradient, we're never going to get voltage off the earth. There's always a potential, whether it's improper case to neutral connections at the dwelling, concentric neutrals in utility that are deteriorating, other different types of connections that potentially could put it onto the earth. Pool, if it's a conductive pool shell, it's rebar and concrete. It basically acts like an electrode, although it's not, but it acts like, and it's sitting there. And there's a possibility that it could get a voltage to it, and in people that are in the pool and they're stepping out of the pool, and there could be some difference of potential that creates this voltage gradient, and they could get shocked, or they could be in the pool, reaching out of the pool. So we're never going to get rid of it, are we? What we're doing is we're trying to mask it, if you will, bring everything up to the same potential, if you will. So there is no voltage gradient. It's all brought up. So we're going to bring up the perimeter. We're going to bring up whatever the pool may have if there's anything in the water, we're going to bring all that up to the same. And then anything within 5 feet that's metal, we're going to connect to it as well, to the equipotential bonding grid, so that everything is at the same potential. It is kind of the way we do it on the supply side of a service. Whereas we don't have any overcurrent protection, but we are allowed to connect the metal parts to the grounded conductor. And we're not going to clear any overcurrent device, probably, but we're going to reduce the touch potential because we're putting everything at the same potential. Kind of concept, same concept, maybe a little, something like that. But I just want to make it clear that we're not getting rid, by doing this, we're not getting rid of any voltage that may be imposed onto the earth or into the pool. It's just keeping it from having a dramatic gradient effect that could create 2 different potential points that could cause current to travel at that point. Okay, so Anyway, that's what we're covering. That's what our goal is. Try to explain that out. And that's why we're doing it. So that's a performance. And again, it doesn't matter whether or not it has um, the power or not. Doesn't really matter. Okay. Electrical equipment. It's not the point. It's, yeah, that's performance. That's what we're doing. That's why we're trying to do all this. Now we're going to get into the elements that we have to do. Bonding. Right? So the first thing we're looking at, again, by the way, we are looking in 2026 again, for those that are jumping into this one. We're looking at the link, which is provided by NFPA. So you can kind of see what it is for technical accuracy. It's easy to look at this for you to be able to see what we got going on. So here's what it says, the bonded parts. Say, okay, the parts specified in 680.26b1 through 680.26b7 shall be bonded together, and shall be. So this is not optional, right? This is mandatory. Bond them all together, right? Using one or more of the following. So I think one misconception that we'll go on and throw out there real quick before I even get started is that some people think that you don't you can daisy chain things together, or they think you have to do like a star pattern where you come away from the conductive pull shell and go out individually to each thing that would need to be bonded. It's not really what it's saying. I mean, I could run a single one and connect things together, or I could run individual bonding conductors, which is totally different than the things having to do with the equipotential grid. These are connecting things together, right?
Yeah, so the language is really telling us, but get them connected together. Things of list time. The path you choose to get them connected together, or how you daisy chain them, they actually get connected together. Your choice to go to point A to B to C to D, or A to D, back to B, back to C,
Yep.
back to however you get them connected together.
Just
It's
connect it
dealer's
together.
choice, right? It's installer's choice out there. Just get them connected.
So in doing that, one of the first things, B1, is okay. So in doing so, connecting all these parts together, you're going to get some options of what you can do, what you can use to connect all these things together, right? So the first one is solid copper. We're probably very familiar with that.
Mhm.
And you see that in the 2026 edition of the National Electrical Code, it says, or a 40% copper clad steel conductor, right? So whether you're using solid copper or you're going to use a 40% copper clad steel, Vince, have you seen any of that anywhere? I have not actually seen 40% copper clad steel.
I have a sample piece of my list, but
Sample.
that's about the only thing I've seen be able to.
So with that said, whether it's solid copper or 40% copper clad steel, it's got to be, it could be insulated, covered, or bare. Okay. Not smaller than 8. And I think the key thing to remember here is this is the element that's tying things together. I think people get confused when they see, wait a minute, it covered or insulated. If you remember the old method that we used to do this, and you're going to hear us refer to this back where it used to be, where you could run a single 8 gauge around the perimeter of the pool, that had to be bare. That had to be solid, right? In that scenario, it would be pointless for it to be insulated because it's got to be in contact with the earth. What we're talking about is the element of bonding all of the parts together. I can use is solid copper still remains, not stranded copper, solid copper, but I can use 40% copper clad steel. But we're talking about what can be used to connect all these parts together that are required to be bonded together. That's what it's talking about in the first one, B1, right?
That's correct.
So let's see here. Let me go back here. So, okay, so it's got to be insulated, cover, or bare. So it can be bare, be insulated, or it can be covered with inside of some jacketing material. Okay, so you have different options, however you might run it. Not smaller than an 8. Okay, are not required to be extended or attached to a remote panel board enclosure, service equipment, or electrodes. So first of all, it's pretty clear in the code that this is not an electrode. Okay, we're not using this one electrode. It may look very similar to a concrete case electrode. If it is rebar and concrete, that's not what it is. We don't take this bonding of these parts. We don't take any of this all the way back to a remote distribution panel, the pool panel, We don't have to take this, although it's not saying we can't.
That's correct. You're not required
We're not required to do it. And I would argue that based on the fact that it's all this area, I would say I wouldn't, but you're permitted to do it if you want. But I would think it'd be pointless for me to run this all the way back to a panel. Why? What am I serving? Okay. I'm not putting it in to clear an overcurrent protected device, right? So, I mean, why am I doing this? Why do it? But you can, and that
to.
type
Right.
of thing.
And that's why I think the more folks get comfortable with the concept of what the equipotential bonding is there for, and you already mentioned it, right? The lead-in language, parent language here at 68026 says it's there to mitigate differences in voltage potential. So first we have to accept the fact that there could be voltage in the ground from all those sources, or one of those sources that you mentioned, utilities, improper grounding and bonding at our premise of wiring, maybe improper grounding and bonding at your neighbor's premises,
That's right.
or the structure next door, the building next door.
Yeah, yours might be perfect. It's your neighbor that's causing
That's
the
leaking
problem.
some voltage into the ground for whatever reason. So we have to accept that this happens. I know a lot of people want to disagree with that, but that's okay. You can't disagree. We just have to, you don't have to like it. You just have to accept the fact that, yeah, this happens and 68026 is trying to protect us. How do we do that? We connect all these things together in the pool to put them at the same voltage threshold, whatever that voltage is, right? It could be 0 volts, it could be 10 volts, it could be 120 volts. Whatever that is, we connect them all together. So knowing that that's the purpose of equipotential bonding, taking an equipotential bonding conductor now back to our service equipment, for example,
Or the pool panel.
what
Or
is
any of
that
that.
really? Does that help put anything at the same potential around the pool area? And I think, honestly, I don't think it enhances it. It helps it. It doesn't hurt it, but it doesn't
It's not
do
helping.
anything above and beyond it. So, but I know there's folks out there, like I said, I've run into them all across the country as speak about this. And they just are determined, feel it absolutely necessary to take this an 8 gauge back to the service equipment and land it in there. And I would say you can do that. The code doesn't say you can't. It
But
says you're
just
not
understand what the
required to.
purpose is of the
Yeah.
equipotential
What's the
bonding grid.
purpose? And are you are you accomplishing anything more, or are you just spending a lot of extra labor time and money to accomplish that? But if that makes folks feel better and sleep better at night, go ahead and do it. So it
Admit
doesn't
it.
say you can't.
Right.
So I would say if that makes you feel good, then you want to do that, go ahead. But it's not a
As I say, you do you, boo. And we'll go. So whatever. All right. And then of course the third one here is are permitted to encircle the pool to facilitate bonding connections to portions of the perimeter covered in 680.26B2A and 680.26B2B that are not contiguous or whatever. So in this case, I don't think I want people to get confused and think that this has anything to do with encircling being uh, being uh, the old 8 gauge that can run around a single conductor that can run about that's not what this is talking about. This is saying the ability to run a single and encircle it to facilitate possibly the connection of all these other things that maybe are within 5 feet that have to be bonded.
right.
So it's this, we're not talking about running the 8 gauge around here and that being the actual equipotential bond. We're saying that you could run encircle the pool with a solid copper or a 40% copper clad steel conductor to facilitate connection to other things that need to be bonded. Allow you to do that.
So if we throw an example, got this permanently installed pool and backyard or wherever it is, got a all the way at that end of the pool, the north end of the pool, within 5 foot, there's a metal fence. But now go to the south end of the, 50 foot away, 100 foot away, however far that is. Maybe there's a metal door frame that is metal within a 5 foot that has to be bonded, equipotentially bonded also. So this language would say, as an example, right? You can attach an 8 gauge to the door frame, 8 gauge wire, copper, solid, drop down, run it alongside the pool to get over to the fence. other end. That's what this language is saying. You're permitted to do that, put it in this area, but this is not, to your point, this is not the perimeter surface language that we're going to look at. And I think that's in list item 2 or 3.
Yeah. So again, this is just interconnect, giving you the ways to potentially connect and bond metal parts together that could be on all different locations around the pool. And this gives you the ability to do that. It's also important to understand this because sometimes you'll have a pool, for example, that is non-conductive. You'll have a vinyl lined pool or you'll have a fiberglass pool that is not a conductive pool shell, but that doesn't remove the fact that you still have a perimeter requirement. Right? So again, depending, and you'll see in different applications, this is just giving you another way to bond the metal parts, to be able to bond the metal parts, especially if you have an area where it isn't the perimeter requirement, the 3 foot out and around is not continuous all the way around and it breaks it for whatever may be the reason. This allows you to get to that other piece of that needs to be bonded. That's all this is really doing. Now it goes on to give other ways to do it. Doesn't have to be solid copper. I mean, it could be done with rigid metal conduit of brass or other identified corrosive resistant material. It could be so structural reinforcing steel. I think that's more like the rebar, right?
Mhm.
And then you've got structural welded wire reinforcement. That's like the wire mesh. And as we'll see, there's its own ASTM standards or whatever for this stuff, but I think it's more or less just like the welded fence wire that we're familiar with putting in the for a structure and structural integrity to the decking from cracking and things like that, right?
Right. This is, I've heard it called out a few different things depending on where you are in the country. This is typically the welded wire that the concrete guys put in the slab for additional structural reinforcement if it's called for.
Yeah.
Typically, it's not something that electricians install,
No.
but the code now gives that as an option.
Well, I'm an electrician and it's there. I'm going to use it.
Yeah,
right.
and
And
it's certainly permissible now.
and for years, this was the wire mesh like this was probably the most cost effective way to be able to do it. If you didn't bring your rebar all the way out or did things like that, then use this wire mesh, roll it in there, connect it together, and use that. Okay, so so you have different options here to interconnect all these parts that need to be bonded together. At least I like to think at least you're given some options, and then the code ultimately will also say that the connections to bonded parts shall be made in accordance with 250.8. That is our list in 250 of the different types of terminations. And of course, and 680.7c. And of course, we click that. That's just a reminder that the terminations and all that have to be designed. Again, direct burial use, that they have wet location rated. And obviously, if they're rated for direct burial use, they're going to be okay for wet location.
Right. So folks who didn't look at the part 1 that we to go look at that portion of the report to make sure you look at general requirements also.
All right. So now we're going to look at, let's see here, the conductive pool shell. All right. So conductive pool shell. So this is the portion, if you have a pool, for example, this is where the pool sits, right? So this is a conductive pool shell. So I can have rebar encased in concrete. I could have block. I could have block is porous. Even if it's painted, it's still porous, absorbs moisture. All of those are conductive pool shells that you could have. Cast in place concrete. What is it? Actually, all of the options that the code says here is right here. It says conductive pool shall be provided as specified in 680.26b1a or 680.26b1b. So it reminds us that cast in place concrete, pneumatically applied or sprayed concrete, and concrete block with paint or plastered coatings shall all be considered conductive material due to the water permeability and porosity, right? So all of those, there's people in the past that say, well, I'm using a block. Hey, I grew up with a pool that was kind of a community pool we went to, and it was designed with cinder block,
Mhm.
and then it was painted over it or coated over it. Um, that's still a conductive pool shell,
Yes, absolutely.
you know. So now, once we establish that it's a conductive pool shell, right, and we have to establish what is not a conductive pool shell. So when you look at the NEC, it makes it clear right here in the last sentence. It says vinyl liners and fiberglass composite shells shall be considered non-conductive material and are not subject to these requirements that we're getting ready to talk about.
Right. So
Now, that doesn't mean that the perimeter doesn't apply. This is
exactly,
just when it comes to conductive pool shell.
exactly. So we have to be careful as we maneuver this language.
All right. So assuming we have a conductive pool shell, first requirement here says, okay, it says structural reinforcing steel, unencapsulated structural reinforcing steel rebar shall be bonded together by steel tie wires or the equivalent. So yes, just connecting them together with steel tie wire is fine. Okay.
So
Uh,
so let's stop there for a second.
yep.
This is somebody dug a hole in the backyard
Like a hole.
or in the back of a building or wherever you're at a hotel, they're putting a pool in, whatever the case may be. There was a hole dug in the ground and the pool is formed with rebar.
Rebar.
That's what this requirement is saying. And so far, the only thing it's telling us is all that rebar has to be tied together with the tie wire,
Act as one.
right? So far, we on the electrical side of the world
We
have
haven't done anything.
absolutely nothing,
We've done nothing to this point.
right? We don't have anything to do yet.
Yeah.
Yes. Okay.
So we're
Just to be
using
clear.
this. We're using the structural reinforced steel to create this conductive pool shell.
Yep.
Okay. Yep. So far, yeah, you're right. We haven't done
We haven't
spot.
had to do anything.
We
There's
ain't done
nothing for us to do yet.
All right. Now it says where structural reinforcing steel is encapsulated. And again, I think we were talking earlier. I don't think I've seen one, but again, you
I've seen a
scan it.
couple.
Have you? Okay.
Right? So this is where the rebar is encapsulated in a or has been coated with or dipped in a non-conductive.
Like an epoxy.
Yeah, it's an
material, something
epoxy
like that.
coating. If folks have ever really driven along the highway and you've seen roadways under construction,
Mhm.
sometimes you'll see a pile of steel rebar sitting there, and it's kind of a lime green epoxy coating that's
Yeah.
on it. That's what this requirement is talking about. The rebar has been encapsulated in this non-conductive coating. And if that's the case, somebody dug the hole, now they formed the pool with rebar, but the rebar is this encapsulated rebar in this epoxy coating. Now the code is going to say, well,
Okay.
let's see what it says.
Yeah. Well, the coach goes say you're not gonna get away with using that rebar now.
Right?
Right.
Yeah, you're not going to be able to just get away with the tie
Yeah.
wires. It's going to say what? A conductive grid
Yeah.
has to be installed.
So this is again one of these, different, and you're trying to. It's a conductive pool shell, and it's being constructed of the structural reinforcing steel. If it's unencapsulated, you're great. If it's encapsulated, then it says right here, it says where the structural reinforcing steel is encapsulated in the non-conductive compound, it says a conductive grid shall be installed in accordance with 680.26B1B, which is right here.
Which is right below it.
Now, this is where it gets more work. This is where, again, the electrician, I don't think he'd be involved in it, but he can cause a real problem for him at this point. Because if they're using rebar, he didn't have to do anything. Right? He's going to connect it, put the perimeter around it, connect it four corners, move on his way, or whatever he's going to do. Whatever he's going to, or how he's going to do it. Maybe four corners in the old way, but now, so not in a new way. Okay, that we're going to see. All right. So anyway, if it is encapsulated, then it's non-conductive compound. So that rebar is simply there, structural now. That's it for the pool. Not going to help us with the voltage gradient. It's not going to help us with anything like. So now we got to go and do a grid. So here's the grid, conductive grid. Now this isn't new, folks. This has been around. That's like I said. At least the conductive grid aspect of it's been around. Obviously, this 40% copper clad steel is new, but you always had the choice to have the grid, or you could do the rebar. in those scenarios. The conductive grid was there before.
Yeah, this requirement was in last code cycle before, but again, this is, can't drive the point home enough. For this requirement about the shell, this copper grid language that we're going to look at is only needed when somebody dug the hole and put the rebar in that's
And encapsulated.
coated, encapsulated. But I see folks or not understanding this and saying, or thinking the code says somebody dug the hole and dropped a fiberglass pool, one-piece fiberglass pool in the ground.
Yeah.
And misunderstanding that they think this copper grid now has to
go under the fiberglass.
Under the fiberglass. That's not what the code says. The code is saying this is only in play
when it's a conductive pool shell.
When the rebar is epoxy coated in that non-conductive. That's the only time this grid is in play for underneath the pool. Right? Because now that's what we're talking, the shell of the pool. We're not up on the perimeter surface yet.
Nope, haven't got there yet.
About the conductive shell of the pool only.
And I guess that's why it's so important for us to have to go back here and read this portion right here, which again reminds us that vinyl linered and fiberglass composite shell shall be considered non-conductive and are not subject to these requirements. So you just simply get to ignore. But yeah, I can see people requiring to do certain things, and they forget the fact that this says, look, it's not applicable. You don't have to do any of this. It's done. Now that's for this. That's for the conductive pool shell. You still got perimeter, you still got bonding within 5 feet, but we're just talking about a conductive pool shell. That's it. So let's look at this grid. So let's assume we have a pool, and I'm going to tell you, like I said, as many pools as I've done back when I was a contractor and I did quite a few pools, I never saw the epoxy coated rebar. It was always just rebar.
Yeah, I never had to deal with it as a contractor. Like I said, I did a lot of pools back in my contracting, but I did see a handful of pools, not that I want, but I did see them out in the field, just 3 or 4 where they use the.
So did you see a copper grid under them?
I did not. I wasn't there for an inspection.
Oh.
I saw them under construction.
I'd say that's critical, because if they got rebar, in order to meet the rules and get this copper grid, it would have to be underneath that rebar. So if they've already got the rebar in and it's epoxied, and I'm looking over in that hole and I don't see something else, the copper grid, then it's something's wrong.
That's correct.
You know, I'm like, okay, now whose mistake is this?
The good news is this doesn't happen that often. To our point, right? I've seen a couple. You haven't seen any, so it's not a typical installation to use epoxy rebar, which in this instance, that's good.
Yeah.
So folks don't have to deal with the conductive copper grid.
But if you did,
it's here, and you have to deal.
And it's got to be copper,
yep,
or 40% copper clad steel conductor grid shall be provided in accordance with the following. Okay, number 1, it's got to be constructed of a minimum of 8 gauge bare copper or 40% copper clad steel conductor bonded to each other at all point and crossings in accordance with 250.8. Of course, 250.8 is all of our connection allowances. Okay, more notably, this would probably be split bolt, something like that. But
well, in all honesty, I don't think folks are building this in the field.
No, I think they're buying it's already pre-welded. It's a mat. They roll it out.
Yeah.
Well, I don't think that I'm not sure if they would buy the mat that is as wide as pools, or they would buy them in 10-foot pieces or whatever the roll is, and they lay it down and it overlaps.
Correct.
And then they would tie these together. Okay?
I mean, the code certainly is giving you the option to build this on your own.
You can, if you wanted to
8 gauge wire and string
it out. Yeah.
But I think the reality is, look, you'd have to hit the spacing requirements out of here. They have to be laid out accordingly. But I think the real kind of killer is every time the 8s cross, they have to be connected for the language here by 250.8.
Yeah, that's a lot of split bolts. So that's a lot of,
who in reality is going to spend all that time to string the 8 gauge out and space it rightly?
And even if you could CAD weld all those connections, who's going to sit there and try to do that at every cross point?
Yeah.
Because as we see, to do this, okay, it's got to conform to the contour of the pool, basically, cover the whole pool, the contour of it. Now, they have to be arranged in 12 by 12 inch squares, okay? And a uniformly spaced perpendicular grid pattern with a tolerance of 4 inches, give or take.
Right.
Okay, so that may lend a tendency to think people could make one and have a little bit of tolerance. If these are manufactured, made in sheets or like reels, you're going to roll it off, then they're going to be uniform, right? The manufacturer is going to
Right. The reality is
gonna
this
be
is
fine.
that language is letting you go up to 16 by 16,
Yeah.
16 inch. And that's, I think if you go purchase the copper grid, some folks call it the copper grid mat,
Yeah.
copper grid mesh, Code just calls it the copper conductive grid. Those manufacturers, I think, are manufacturing 16 by 16
Are they
because that's what the
maximizing their distance, maximizes, uses less copper?
because the code permits it.
Yep.
The 4 inch tolerance.
Yeah.
Somebody could fact check us
Yeah.
on that though.
Yeah.
Pull up about a manufacturer who makes this stuff. Double check the size.
And many of the people out there probably have never done this either. You know,
Mhm.
they've never been involved in using conductive grid like this. All right, and 4 it says be secured within or under the pool no more than 6 inches from the outer contour of the pool. So again, follows the contour, and it's going to be close to the actual contour of the pool. You know, not more than 6 inches, right? So it's going to follow the contour very closely. So again, covered that pretty quick. Moral of the story, I think we covered that well, is that at the end of the day, you either have a conductive pool shell or you don't. If you have a conductive pool shell, uh, now I guess the other one would fall in, Vince, is this is saying use structural reinforced steel. What if it's a block style pool and you don't have structural reinforcing steel because it's block design, then you're going to have to go with the grid because it says right here if it's cast in place concrete, pneumatically applied and sprayed concrete, and concrete block, then it's a conductive pool shell. So anybody designing a pool like that is going to have to use a grid because they're probably not going to have any rebar in it.
Or I think if there was some rebar in the block, in the hollows of the block, I mean, we'd have to look back at the language here to see
Well,
if that were. I think that would
there
be
is no,
permissible
yeah,
if
there
it
is,
was tied together.
yeah, it doesn't give like a pattern, a grid, or how much you got to have for this. It's just basically structural reinforcing steel. So if you're putting rebar in it and it's considered structural reinforcing, I can be honest with you, if I'm building a pool and even if it was block, I'm driving me some damn rebar somewhere because the thought of putting in a copper conductive grid underneath all that, hard pass.
Right.
That type of thing.
But you make a good point. That may be something that has to be called out. That this block does put steel in the hollows of the block. Is
Yeah,
that
I mean,
going to comply? I mean, I would.
it's a code panel. Maybe this should be a, kind of like we have concrete, the concrete case electrode. There's a certain number of feet, a certain number of concrete of rebars. When somebody does build a block and it's just plaster painted, like I said, I grew up with a pool that was designed with concrete block. It was like a neighborhood pool, community pool. Wasn't real deep, but it still would have been, still was a pool.
And the code is telling us it's porous. It's telling us it's a conductive shell.
So
you're
that's
gonna
saying
need
you
to
either
deal with
using
it.
reinforcing steel or you're going to put a grid in.
Yeah, the question I think the gap here is if you're going to put rebar in there, how do you? There's nothing in the requirements we're seeing here are telling us how to space it.
No.
But if it is in there, it would have to be connected together with tie wires.
Yeah, and I don't know if 17 wants to get into the designing of the pool. We know that if it's a structural reinforced steel that's all made up of rebar, then it is a lot of rebar, and it's the foundation of everything. Whether they're spraying gunite on it or whatever, I mean, it's the foundation. Everything with the block, it would not. So the real question is, again, comes back to that old saying: what is it? If they drive one rebar every 5 blocks, is that enough? Is it even necessary I mean, is it enough to have the concrete block that's porous? How important is the rebar or the structural steel? Is it structural or is it you just putting it in there in order to try to get away from not putting in the grid? Because
That's what I would try and do.
yeah, yeah. Because I mean, if there is absolutely no structural reinforcing steel in it, It's just block, and the block says it's conductive. It almost forces you to say, well, and then how much rebar in a block would be necessarily structural support or just
Yeah, it's the code is silent right now on that, but I think it's a good point that you about how would folks deal with that. I guess a block is not a common installation to do a pool
yeah.
to use it as material, but certainly to your point, you've seen them.
Hmm.
I've seen them, not
Yeah.
too often, but they are out there. But
I grew up
probably
with one
not
right
the
down the
common.
street from my house. Yeah.
Yeah, the common. But good point on the block.
But good news. If it is structural or reinforcing steel, you're good to go. If not, copper grid, and again shows you how to lay it out and everything. Okay, so that was pretty straightforward. Again, we established that if you have a vinyl pool, and I can tell you, it doesn't matter what's under the vinyl. I've had this go around a lot with people like, well, it's a vinyl pool, but underneath it, it's a it's something else, and I'm like, look, when we're talking about a conductive pool shell, you may have other elements that are metal, but as far as determining whether it meets B1, is it a conductive pool shell to require this requirement here? And if it's vinyl lined pool or if it's a fiberglass, it is not a conductive pool shell. Skip B1, move to B2. And B2 is going to talk about the perimeter.
The perimeter surface.
Perimeter
Right.
surface around it. So let's get over here. All right. Okay. First off, I'm going to tell people right now, we spent a lot of time talking about items and breaking things out to understand it a little better and getting some items stuff. I'm going to tell you, first off, and first glance in this, Code Panel 17 done dropped the ball here because these are a lot of paragraphs. This is a lot of run on information. Here, we're going to talk about the 3 foot, yada, yada, all the way. Then you're going to get down to here. That's a lot of information. Then you're going to get down here. That's a lot of information. And then it starts going out into 1, 2, 3 type of thing. So, yeah, I would probably say this could be broken up a little bit. But let's look at it and see if maybe it's really not necessary. It just flow. Maybe it flows okay.
I think it's better than what we had previously. And we'll leave
Feels
it
better.
at that.
Leave it at that. Okay.
No, I'm not saying by no means is it perfect. To your point, it may be some list items are needed here. That certainly could be. There's always room for improvement,
Absolutely.
right? Put it that.
But again, this is one that's been tackled for 3 cycles now, at least, right? Trying to
Easily.
change up the language on this equipotential bonding to make it a little
Easily,
easier to
right.
understand. All right, so let's read it here. So bonding to perimeter surfaces shall be provided as specified in 680.26B2A, 680.26B2B, and 680.26B2C. Okay, so we're going to have this is going to be broken down into an A, a B, and a C. It says the perimeter surface shall include, so we're talking about the surface around it. It shall include unpaved surfaces, grass. Okay, let's just say unpaved grass. Okay, it could be gravel, right?
Correct.
It's unpaved surface. Concrete, masonry pavers, and other types of paving
So
could be around it. Okay?
it's whatever you're walking.
Wherever you're walking.
This really should say the perimeter surface shall include whatever you want.
Whatever
It's whatever. You could say it's paved. You can say it's unpaved. You could say it's pavers, mason, whatever it is that folks are walking that fit inside the dimensions that we're going to look at. It is the perimeter surface. Some folks will call it the deck. Deck around
the decking
pool,
around
the
it.
decking around the pool. That's
The surface we're walking on.
yeah. So let's stick for our conversation. Let's just keep so nobody's confused. It's the perimeter surface because that's the language that the code uses. Whatever we're walking around that fits inside the dimensions of the perimeter surface. Whatever that is, right? To your point, grass, gravel, concrete block, pavers, concrete itself, whatever it happens.
I'm on the same. I'm trending the same page. So we'll go with that perimeter surface. Now, it says the perimeter surface to be bonded shall extend 3 feet horizontal beyond the inside wall of the pool at the height between 3 feet above and 3 feet below. Again, you could have different contours, different grade, grading, landscaping, all this kind of stuff that go up on a hill beside the pool. You could have it drop down on the edge of the pool, kind of down a hill or a little bit of a slant or whatever. So it's giving you this 3 foot out, right? And it's saying, okay, so this could be go up 3 foot above, up 3 foot below, but it's still the 3 foot around
Right.
the
So it's a
perimeter
it's a
surface.
it's a three-dimensional bubble. Well, that we have to think of it three out, three up, three down, carry that three-dimensional shape around the of the pool. And that would be the perimeter surface. When you are outside those dimensions, you go 3 foot 1 out, you go 3 foot 1 up, you go 3 foot 1 down.
You're outside.
You may be walking on something, but from equipotential bonding perspective, you're outside the perimeter surface dimensions. So you would not have to provide equipotential bonding to that surface you're walking on, because you've just
And it
left
makes sense,
the
right?
perimeter
Because
surface
again, all
there.
we're doing this perimeter surfaces again for voltage grading. So you're further than 3 feet out. You're not, where you're stepping or how you're stepping. You're once you're that far out, you're not in there where you could have a serious issue of potential voltage gradients that could create a problem. Whether you're
Let's
stepping in
hope.
the pool and
Yeah.
stepping out, unless you're 7'9" and you got a 4 foot gate on you that you're just well, I mean, typically you should be once you get past 3, um, you should not have an issue. So we limited at 3, but we have to take into effect, like you said, it's around the perimeter could be angled down, could be angled up slightly.
Or you could have
change.
steps going around.
It's steps, yeah.
And I may have some pictures in the slide
Okay.
deck that highlight that, some different levels from the surfaces around the pool. Try and look at those. I'll put a picture or two that may visualize this.
Trying to look and see if we do, and I think you do. Good, yeah, okay. Because I think I saw it jumped to the 680.26b2 non-conductor perimeter surfaces, and then I was afraid that it skipped all of the other surfaces, so I didn't go look at it. But
Okay.
it looks like it does have some, so we'll go back and look at it. All right, so let's cover the code first, and we'll go back and look. Okay, so 3 foot out from the inside wall of the pool. Okay, 3 foot up, 3 foot down. Again, accommodate steps, change in elevation, whatnot. So again, 3 foot. And it says at a height of 3 foot above and 3 foot below the maximum order level. So good, we're back to the maximum order level, the point where it comes out of the pool. Okay, where it comes. Perimeter surfaces separated from the pool by a permanent wall or building 5 feet in height or more shall require equipotential bonding only on the pool side of the permanent wall or building. So if it's a wall, it may not have what? I guess if I'm looking at the language here, I'm saying, okay, so if our perimeter surface separated by a pool is a permanent wall, and that wall is 5 feet high, so I don't have to go fully 3 feet out, right? If I have a wall and that wall is a permanent barrier and it's up and it goes up at least 5 feet, then that 3 feet can actually stop. Maybe it's 2.5 feet.
Yeah, so I mean,
Stop at that wall because that wall is a 5 foot barrier. It's breaking that 3 foot measure.
right. So I think an easy visual would be someone adds a pool to an existing building, and that pool is a 2 foot walkway, 3 foot walkway left between the edge of the pool and the edge of the building, the side of the building, or sliding glass doors or something that leads inside the building. Well, you don't have 5 foot.
Right.
I mean, you do, but the other, in our example, if it was a 3 foot walkway, 4 foot and 5 foot, you have to open the sliding glass door to measure the other couple of feet.
Yeah.
The code is saying, no, you don't have to do that. You've got this permanent wall. It goes up at least 5 foot. The measurement stops there when you hit it.
That's it.
So that kind of makes sense, I think.
Agree. Yeah. Now it goes on to say for conductive pool shells where bonding to perimeter surface is required. So this is if you have a conductive pool shell,
Right. So this is specifically, you have the conductive pool shell that we just
not a
talked about.
fiberglass, not a vinyl pool.
Right.
It's conductive pool shell. So it says where it's bonded to the perimeter surface is required because we have a conductive pool shell. It says bonding shall be attached to the pool structure, reinforcing steel or that copper grid we talked about. And you know, they probably, well, this talks about 40% down here. So anyway, so it's got to connect to that grid or the reinforcing steel at a minimum of 4 points uniformly spaced around the perimeter of the pool.
Yeah.
Okay,
So this is finally, we have the language, the requirement that says make a connection from the perimeter surface down
to the pool shell.
the conductive shell, or maybe it's the copper grid because the pool shell had the epoxy coated
Right.
and the copper grid had to be used. So this is somewhat of a delayed language, if you want to think about it, that says make a connection now down to the pool conductive pool shell.
Sense to me. Then it goes on and says if the bonding perimeter surface does not surround the entire pool, bonding shall be attached to the pool reinforcing structural steel or copper or the 40% copper clad steel conductor grid at a minimum of 4 ununiformly spaced points along the bonded perimeter surface. So either way, you're going to make 4 points. Okay, either they're uniformly done. Either way, if it isn't, you're still going to try to make 4. Is it 4 uniform? Either way, aren't you still going to have to make 4 uniformly spaced points on the perimeter? I mean, either way, you're going to have to try to make it this connection.
Yeah. So let's say we have as an example, we got a square pool. We got 3 sides of that pool where the perimeter surface is flat and even with the top of the coping.
Yeah.
Everything's even.
Yep.
But when you get to the 4th side, you go down 3 or 4 steps or 5 or 6 or 7 steps. And to that 4th side, that surface is way down lower.
Yeah.
Let's say it's 4 foot lower. Let's say it's 3'1".
Right, right.
Okay.
Because a 3 foot was up or below.
Right.
Right.
Because the perimeter surface language tells us 3 foot out, 3 foot up, 3 foot down. So if I went to that 4th side of the pool and that surface that I'm walking on at 4th side is 3'1" below the maximum water level of the pool, I think the language is telling us, well, you don't have any equipotential bonding to deal with there because that perimeter surface is not in the 3 foot by 3 foot by 3 dimensions. So I think this language is saying, okay, now those 3 sides of the pool that are flat with the coping, that's a perimeter surface. You do 4 uniformly spaced.
The portion that is bonded, but it's saying that portion that is not, it's outside of the 3 feet, and not required. Bond that portion. And then again, for a non-conductive pool shell, okay, so again, that's your fiberglass or your vinyl lining. That's a non-conductive pool shell type. It says where bonding to the perimeter surface is required, bonding at 4 points shall not be required, obviously, because there's nothing for that perimeter to bond to. It's a non-conductive pool shell.
Right. There's nothing.
No 4 corners to do anything.
To connect.
So do nothing there. Doesn't remove the fact that you still need the perimeter.
Right.
But it's just saying there is no conductive pool shell to connect to. It says the perimeter bonding shall be attached to an 8 AWG copper or 40% copper clad steel equipotential bonding conductor, and if present, to any conductive support structure for the pool. So ultimately, you still have to have in a perimeter. You can bond certain elements together with this 8 copper and 40% copper clad steel equipotential bonding conductor. And if present, to any other conductive support structures. This is not saying that an 8 gauge can be used around the entire perimeter as an equipotential bonding.
That's correct. So think of and I've heard this. I've never seen it myself, but I've been told in a couple of installations for fiberglass pools,
Mm-hmm.
basically dig the hole and set it in place. That there are installations, and I guess it may depend on the size of the fiberglass pool, where they actually have metal cradles that they sit the fiberglass pool into.
Okay.
So they dig the hole, they put these metal cradles to support the fiberglass pool.
Is that to keep it from
For whatever
floating up,
reason.
maybe? Is that just to hold it down, or is
Like
it
I said, I've never seen them. I've only been told about them.
okay?
So I think those metal cradles would become something metal within 5 foot of the pool.
Okay.
So I think this language is saying now, if you had that type of installation, you would go from the perimeter surface and make a connection to the metal cradles
With an 8 or
with an 8 gauge.
8 gauge copper or 8 gauge 40%
But that's,
copper.
these are
steel.
kind of one-off type installations, but I think that language would address.
And I would agree, because if you read the actual informational note down here, more importantly, this portion down here, it says an 8 AWG copper or 40% copper clad steel equipment bonding conductor, equipotential bonding conductor can encircle, and we saw that earlier, can encircle the pool, even if it's not part of the equipotential bonding grid, but to facilitate the connections of all the parts that we bonded. So I think that is what it's saying as well for the non-conductive pool shell. I think that it's saying that you would use an 8 or 40% copper clad steel to be able to bond to those other components, right?
Right, but not use it to bond, to use that in the
Yeah,
surface.
not to
Same
be the
thing.
perimeter surface, just to make the connections for the perimeter surface. Different ones. Yeah. I will agree. So let's go over to see where if we could catch up here. If you have something on the slide, we'll do here. So this is an example of the rebar we saw earlier.
Yep, that's certainly a conductive pool shell.
Yep.
And
Spray in.
now,
Right.
right,
It's like a spa over here because I see the air jets that are being installed.
Yep.
Yep.
So, in a typical way that, I mean, if you have this installation, what I always saw was before this was shot with the gunite, folks would take a piece of 8, maybe 4 foot, 6 foot, 8 foot long. One end of it, it's split bolted to that shell, piece of rebar in that shell. 4 points uniformly spaced around the pool, and the wire would just be left coiled up,
laying out near the perimeter,
laying out in the dirt for now. And then when they actually form the deck later, perimeter surface, the other end of that 8 gauge.
So is that the inspection process where you have a multi-site inspection where the inspector will come out and look to make sure before it gets sprayed that those connections are made? And I'd rather them see those connections than to come and see just a piece of copper laying on the surface. But again, timing and getting the inspection and having them get out there. Well, these guys do these pulls and they get in there and they think of it, they're ready to go. When that truck comes with Econite, they're ready to go, right?
Yeah, so I think that would be, the answer probably changes on who looks at that, if it's required to be looked at. It depends on where you are in the country and how things are cost. I could tell you
We had stages. So in Alexandria, for example, when I was up there, when you were doing a pool, we had a pool bonding inspection.
Mhm.
So we would go there before they would shoot anything onto the pool. We would make sure those connections were there, and we may come back to check the connections to the perimeter at a different time. So it was in multiple stages. So it wasn't like a one and done. You come, oh look, that's great. Copper's rolled out here. I see the 4 corners. You're done. We don't ever come back. No, it was in stages. They would call you before they got to each stage.
Yep, and we had the same thing. Municipality, this would all get different stages.
All right. So you did cover this, but I still think because I'm now looking at it, these are good things to just run over really quickly. There's the performance we talked about, voltage gradient. There's a good example of, and I know you can't see it, and I'll zoom in. There's the rebar. There's, the wet niche that's mounted in here. Here you see a ladder. That's bonded here. By the way, it's also bonded up here. So, but it's here it is down here. Okay, there's the niche bonded. Okay, everything's bonded together.
And that's a rarity. The brass conduit is
Yeah,
right. That most likely you're not going to be installing, and folks are not going to see it.
yeah,
And we spoke about that when we covered the wet niche material
yeah.
in a different segment. That's most in most parts of the country. That's a
PVC.
PVC conduit
Yeah.
going to wet niches.
But here's diving board. Here you see the connection to the lug on the diving board. Connected. All things connected together. Okay. And this perimeter surface again here, probably not 3 feet, but it's supposed to represent 3 feet going out. But the way this gridding is, I don't think that's 3 feet. There's one set of grid there, 12 inches. But it's supposed to be all the way around the perimeter. Okay, so why are we doing that? Again, to address voltage gradients and try to reduce the issue with the voltage gradients that can cause, that's where the problems can be created. We just saw, we're talking about B1 through B7. This is a great illustration we talked about earlier. This is individually, but nothing says that I couldn't daisy chain this.
That's correct. Yeah.
Okay? It's not like a grounding electrode conductor, which can change depending on the type of electrode you're going to, the size. No, if I want to do individually to each one, I can do it. If I want to loop through them, I could do that as well. Okay, you have different options that you can.
Yep. Just get them all connected.
And again, we talked about, and this is some of the aspects of bonding it. We talked about it: reinforced steel, welding material. I don't know if this is the mesh.
Yeah, that's
Yes, it
the
is.
that's the wire mesh roll. That's
There
the
you go.
structural wire
Yeah,
mesh
it's going in the decking, right?
Mhm.
Yep. They go see them pulling it up so they can make sure that they get the concrete down in so it sits nicely in the concrete. Okay, got that. And of course, this one, that is all of your rebar. So that is your conductive pool shell laying all in. And you see they do. I do see some bonding being done through here.
Looks like it.
Like it's a different bondings. Or to get that stuff inspected, man, let me tell you what, do not do it and not get it inspected and then come back later and ask the inspector, well, what
For
can I,
mercy.
yeah, what can I do? You know, it typically is not going to look at you and go, oh, I'll just let you drive 4 ground rods around. That's not how it works. It's not how it works. Although people call all the time and they say, oops, I didn't do an equipotential bonding grid. Can I just get away with adding ground rods or something like that? It's not how it works.
Yeah. Remember the reason why we're doing equipotential bonding, right? We said that 2 or 3 times already. It's really to put, you don't reduce the voltage.
Yeah,
Maybe not the right word in the
it's
beginning.
there.
of 6,
All
8,
you're doing is
26.
masking it so the effects of it are not.
Putting
You don't feel it.
everything at that voltage threshold. That's
Yep.
what we're doing. Whatever voltage is out there. People are familiar with 120 volts. I really hope volts.
Yeah, yeah.
But if it was, the concept is if we put everything at the same voltage. So if we put everything at 120 volts,
Mhm.
it eliminates any step or touch potential difference.
And especially with these pools, because we're probably not talking about anything near that. We're probably talking 3, 4, 5, 6 volts. But if you're in the pool and you're touching, it might be enough to cause you to get discombobulated. Is that a word? It could disoriented.
It is now.
It is, you know, it is a word now. I made it up. It's mine. So it cause you to potentially drown or something like that. Because again, very few deaths happen in pools due to electrocution. The vast majority of the deaths in pools are due to drowning, that type of thing. So think that they get disoriented and and just drowned. Type of thing, I would say. Do I have data to back that up here today? No, but a lot of the reports you'll read of people, they weren't necessarily electrocuted, but they probably drowned, depending on the amount of water that's sucked in, and they can tell that type of thing. Either way, you don't want to be a part of any of that, right?
Nope.
All right, so this is a good one that we can run back and you see cast and and zoom in on this here. Say, so here is the rebar, getting it all set up to do it. And then here is an example. Is this your epoxy coated?
Yeah, that's a
There you go.
coated.
Right. So this, folks, is not a conductive pool shell at this point, right? So I don't know what this is down in here. This looks like maybe tension slab. something underneath it. I see wires going through here. I don't know what this is, but at the end of the day, if this was a pool and this was epoxy, then we're going to have that grid. It's not going to work. Not going to work. And we talked about, okay, structural reinforced steel, again, encapsulated, not going to work. But if we have unencapsulated tie wires, steel tie wires, perfectly fine. Tie it all down. Those guys that do the pools, like as an electrician, we have nothing to do with this. They're already going to take care of all this. We don't have anything to do with it. There you go. There's some a roll of pre-bought right there. Grid, roll it out. It's probably made up of eight gauge copper. Because to be honest with you, I have not seen any 40% copper clad steel. I have not encountered it, but I've seen plenty of copper grid, copper mesh.
Yeah, the 40% copper clad steel, I think up until now, because that's a new allowance in 686. But copper
I
clad
think
steel,
cost wise, you'll now, because it's in there, we'll see more of it. I don't know steel versus,
I don't
you still got copper in it, but then of course the cost of steel. So does it offset? I don't know. Copper is expensive. So.
Industry will figure that out. I was just going to say copper clad steel has been an option back in chapter 8 for grounding of communication systems.
Yeah, and it's used, and it was used a lot on towers.
Yeah,
okay?
it just wasn't recognized in certainly not in 680 applications, but it is. And you know, like I said, industry works through these issues from a cost perspective, right? The folks, installers, contractors figure out what's the best way to go from a cost analysis perspective when it gives you options.
Right.
And folks figure it out pretty quickly.
Cheapest option still, folks, in my opinion, is just a wire mesh. Not for the conductive pull shell, but for the perimeter wire mesh.
Structural reinforcing wire mesh.
Structural reinforcing wire
whatever
mesh.
we call it.
Yeah, that's what we call it now. But again, we haven't even gotten really that far yet. We haven't looked at the requirements. Not right quite there yet. So we're catching up because I didn't realize he had great slides I wanted to show you. So here you go. Here is the grid rolled around the perimeter. May or may not be actually 3 feet. Base, if this was 16 and 16, if these were maximum, it still wouldn't be 3 feet, but you get the point. This is what's going around the perimeter, okay, type of thing. Paved portion. Okay, now we're going to get into the different allowances around it, right?
Right. So far, the code is kind of telling us, yeah, we have to do something up here. It told us we have to do something for the perimeter surface and tie that something to the conductive shell.
Yeah.
Now it's driving a little deeper, and this is kind of fairly new on how this is structured here, where we go into certain requirements when we have a paved perimeter surface, whatever that paving may be.
Right.
You know, concrete pavers, and then we've got other requirements.
We got it unpaved.
Unpaved meaning your perimeter surface is grass or dirt or gravel. That's all unpaved. So little new structure.
And we even have a non-conductive perimeter surface too.
That's right. And that's fairly new language also. So we work through them individually.
Okay.
See where we wind up.
All right. So if we look here, so let's say now, remember where we're at. We're focusing, folks. We're on the perimeter surface.
Right.
We're off of the pool shell now. Perimeter surface. We're in B2. Conductive paved portion of the perimeter surface. Okay. So this is that 3 feet out. Okay. It says conductive paved portion of perimeter surface shall be bonded to one or more of the following. Number 1, unencapsulated structural reinforced steel in accordance with 680.26B1A. That's that rebar, right?
That's rebar.
That's rebar. Number 2, conductive grid made of copper or 40% copper clad steel. Okay? Again, this is when you have conductive paved surfaces, and what would be an example of that, Vince? That would be just like block, concrete pavers, concrete block.
Yep, could be just raw concrete. Well, somebody's pouring concrete, for the surface. Happens many times.
Okay.
But it could be pavers, concrete brick pavers.
Yeah.
It's paving material. So in either of those applications.
So underneath it, This has been very clear. This is what's so important because you remember in the past, folks, there was rules where it started out and everybody did what? They did the 8 gauge single conductor around the perimeter of the pool.
Whether it was paved,
It
unpaved,
didn't matter. That was the
didn't matter.
easy, cheapest solution. That's what everybody did, and everybody maybe there wasn't really any. And I think all the code meetings I've been in, nobody has ever pulled up how that got into the code or what got that single conductor allowance in the code. I have yet to see it. You seen it? I have not seen what introduced that into the code, but it's what we had for years, right?
Yeah, the single 8 gauge has been in there for probably, or was in there for probably 6 or
Was
7
what?
code cycles.
Did you say was?
It's still
Uh,
permitted in very limited applications
Okay.
here, and we'll work through that.
Okay. So the one we're looking at right now, though, is paved surfaces, and it's telling us what we can use underneath it.
Yeah, so
Rebar.
let's drop back conceptually just for a second.
Okay.
All right, we're talking a paved portion, whether that's brick pavers, whether that's concrete, right,
Of the perimeter.
of the perimeter surface. So the code is recognizing, look, that's conductive,
Yes.
right? And folks, we're going to be walking on that.
Yep.
So somehow we have to equipotentially bond that.
Right.
So we
How-
can't just take a lug and
Every
bolt it
paver.
and bolt it to the paver, so bolt it to the concrete, right? Kind of like the concrete encased electrode.
Yeah.
And for a 250 application, we have to put something in contact with the concrete to connect a wire to it, connect something to it. So same concept here. We have to jam something in this paving material that we can make a connection to. So what is the code going to tell us? What can we jam in there that we can make a connection to? All right, what are our options? What can we jam in this paving material that we could
To essentially bond all of this conductive paving
right
material.
to get everything at the same voltage?
All right. Well, the code tells us, and based on Vincent's Lincoln, we can jam
Let's jam
and
something in there. What can we jam in there?
an unencapsulated structural steel or reinforcing steel rebar. We can do that. So basically, you can extend it out from the pool, out over the coping, and take it out 3 feet if you wanted.
Piece of rebar, bend it
Yep.
out of.
Bend it out, curve it out,
Yep.
continue it on.
Absolutely.
And again, another straight piece can tie on it by a simple steel tie wire to extend it out. Okay, that can be done. Can you put that grid? Well, if it's okay for the conductive pool shell, it certainly should be okay to do this as well. So we could use a conductive.
The conductor grid made of copper, right?
Yeah.
This is that.
Or the 40% copper clad steel.
This would be that most likely that pre-manufactured.
Matte.
And we have to meet the no more than 12 by 12 with the 4-inch tolerance of the spacing.
And I
the
think you
dimension
said that maybe
of the-
manufacturers just go to 16 by 16 because it's going to mean less copper.
Okay. So far, things that jam in this paved
We
material.
got 2 things that we've jammed in it.
Rebar or the copper conductor grid.
Right.
What are other choices?
Well, I can tell you this next choice is what I'm going to tell you is the cheapest choice. Okay. In my opinion, or maybe it didn't get cheaper now that ASTM and all got involved or whatever these have to be. But let's look at the next one. So the next one,
Let's see.
I'm going to get there.
Okay,
I'm right
good,
there.
thank you.
I'm here. Number 3, it says unencapsulated steel structural welded wire reinforcement mesh. I guess I'm going to add the mesh in there.
So
Bonded together by simple tie wires again or something equivalent. I'm not sure what would be equivalent. I'm sure it's not a tie wrap. Okay. That would certainly not be equivalent to a steel tie wire.
Mhm.
Okay. But something equivalent.
I guess if, me personally, I would say, well, and I've been asked this, if they used a split bolt to connect the wire mesh together,
I would be okay with that.
I would be okay with that.
That's
as long as it's
equivalent.
listed for direct burial,
Yeah,
just
agree.
going to concrete.
Yeah.
I would be okay with that.
Yep. All right.
Now, how often you have to install those, that becomes.
Well, even with the tie wire, it doesn't say how often you have to do it.
Becomes more of a structural building code requirement.
Right.
I know there's when you tie rebar together, there's a certain lap of the rebar
Overlapping.
based on the bar diameter. I don't know what the requirement is when you use the mesh, the structural wire mesh. But anyway, wire
as long
mesh,
as they're tied together, and I think you could use steel tie wire, and I think you could use split bolts if you want, and I don't think it has to be at every connection point. I just think that as long as they're connected together, that they're
Mm.
probably going to be fine. We'll let the EHJ can dig into that, but at the end of the day, it doesn't give you any more directions other than this. Okay,
Right.
so
And we have to remember the tie wires are just there to hold the steel in place.
yep,
Because once the concrete is poured,
it's all
the
acting as
concrete's
one. Right.
holding everything.
Yep. So with that, okay, so
So we got this paved portion of the perimeter surface,
yep,
concrete.
yeah, it's fully embedded within the pavement unless the pavement will not allow for embedment or bedding.
Like a brick paver.
Yeah, something like that. So, but if it is concrete, then most certainly can be embedded in the concrete perfectly fine, and that could be. And that's, to me, I still feel that's the cheapest method. I mean, I love selling copper. Don't get me wrong. I'll sell copper every day of the week. But the cheapest method is if they already have the rebar there.
Yep.
It's like a concrete encased electrode. If it's already there, but for electrician, that's the cheapest. It's already there. It's part of the structure.
So what's missing from the list? In a nice way, you're saying there's something missing.
Yeah, but the nice way I'm saying, and when it comes to these, I don't get to use a single 8 gauge around the perimeter anymore.
Right.
That
So
should be your takeaway, folks.
takeaway here is in the perimeter surface, one of the big changes with this language, which is really in the 2023, also based
Yeah.
on a tentative amendment that was issued, but that is carried over to the 2026, where the single 8 gauge, and Paul has said this a couple of times, single 8 gauge in the perimeter surface for a paved perimeter surface anyway, is really not an option. It was for many code cycles.
Now, in that allowance, we saw that it would allow unencapsulated structural reinforcing steel. If by chance the construction of the pool was encapsulated, or if that structural steel was absent, okay, not talking the grid, but we're not talking the conductive pool shell, totally different beast. We're in the perimeter now. If it was a mesh option for that because it was encapsulated uh, rebar in the conductive pool shell, carrying over to the perimeter, if it is no rebar, is absent, or if it's encapsulated, then, or if it's a non-conductive, in a non-conductive compound, now what do you have to do? Well, you have it down here. It says, now look, if the reinforcing steel is absent or is encapsulated in a non-conductive compound, or embedding is not possible, then unencapsulated welded wire steel reinforcement or a conductor grid made of copper or the 40% copper clad steel shall be provided and shall be secured directly under the paving and not more than 6 inches below the finished grade. So again, if you're dealing with, obviously in this list, if we don't have number one because it is encapsulated, right? Or if it's not there,
or maybe it's going to be a concrete pour, but the concrete is going to have that fiberglass mixture in it. The fibers, actual
yeah, so
fibers,
it's not reinforced by
not
the
required to be
mesh.
reinforced by rebar, more from a building structural standpoint. It's been determined that fiber mesh, where it looks like after they pour it, if you went there the next day, it looks like it needs a haircut.
Yeah,
It's all kind of the
fiberglass
fibers are kind of out there.
Yeah.
Yeah, so that would not require, maybe from a design perspective, to have rebar in. And the code is trying to recognize this.
Still conductive.
Okay, it's still concrete, it's still paved, it's still conductive. We're still going to have to do something to make a connection to that could potentially bond it.
So you got two other options.
What are the options? Yeah.
And that is you could do the copper grid or the 40% copper clad steel, or you do the unencapsulated steel structural welded wire reinforcing mesh. The difference is it's not going to be within the material. It can be outside of it, right? It just under it, and it just can't be more than 6 inches below the finished grade.
Yeah, and I think if somebody's pouring concrete, they're going to put the welded wire. If they decide that, they're going to put it in the concrete. think the more that would
You
address
think
would
even
be-
with even if it has the fiberglass reinforcing mesh, you think they're still going to put it in there?
I would think so, because
Not so much for the strength, but to save them the headache of the the perimeter. It's much easier just to put that wire in there, the mesh in there, right?
yeah, I think the language is captured. It also captures, I should say, a brick paver installation. So typically with brick pavers, it's dirt, it's a few inches of sand, then
Yeah.
the brick paver gets laid on top of that.
Right.
In that application, well, you're not jamming anything inside the brick paver.
No.
So whatever you use is going to have to go in the sand, or maybe in the dirt, but not more than what, 6 inches?
6 inches below the finished grade.
So no more than 6 inches below the top of the brick paver. So
Right.
it's probably going to wind up in the sand.
Yeah.
So what are your options in that application are the same. It's going to be the
Grid.
copper grid or the wire mesh, structural steel welded wire mesh.
Mhm. And I will say that that's probably in most cases probably going to be the cheapest route.
Yeah.
Although I'm
So
a copper guy, I like copper, but at the end of the day, it is allowed and it's been around. This isn't new. The wire mesh like this is not new.
yeah, the concrete reinforcement wire mesh that the
Yeah.
concrete folks always throw in.
Mhm.
Yeah, that's been around forever. Now I will caution folks to say, and I'm since this is fairly new language in the NEC, I really haven't gotten any feedback on what's happening out in the field. My question or my concern is how industry is going to deal with this is we have the brick paver installation and structural welded wire mesh reinforcement is the option that folks choose.
Right.
And that's naturally going to go in contact with sand,
Right.
most likely.
Right.
And I don't know the correct term for it, so I'll use the highly technical, is the regular schmegular wire mesh that would go in the concrete. Are folks going to approve, or AHA is going to approve that in contact with the earth, not encased in concrete from a soil deterioration perspective? Or are they going to drift to saying, well, it's got to be, and there is this structural wire mesh that's hot dipped galvanized.
Yeah, I was going to say a lot of. I would think it'd be galvanized or
Now
kind of.
the NEC doesn't go there.
No, it doesn't say. It just says the mesh. So
It says the mesh.
now
so
it
folks
does
will have
make
to work
reference
through
to an ASTM standard for the wire mesh. Now maybe that standard has something in it. Again, I never really gave that much thought because most of the time when we got the wire mesh, it was typically used in the concrete.
Right.
Wasn't used thrown in the sand underneath it as an option. Here it's saying it's an option. It doesn't take any criteria other than the fact that says you can use it.
Right. And I think we're not in the building code here.
No.
Right. But I think building codes would say rebar, it's got to be encased in concrete, any kind of reinforced steel. This is not the building code. This is the National Electrical Code.
Yeah. And it's saying that wire mesh can be underneath the paver, let's say, as long as it's not more than 6 inches from finished grade.
So, and again, I'm again, folks watching this, if you have feedback, absolutely put it in the chat. What you're dealing with, I'd love to get some feedback on how this is being enforced.
Yeah, what are you doing out in the field? What are y'all doing? And some of this, maybe you never used the mesh. So you're like, I don't know, I never used the mesh. You always up to these last couple cycles, you got away with running an 8 gauge around it. So maybe a lot of these options are now new for you.
Yep, they are very new.
And this is an example. This is very nice looking. So a lot of nice pavers around. And I think Vince, you pointed out one other time is that we're talking 3 feet here.
Correct.
We're not, even though these are still the pavers out here, the voltage gradient issue we're worried about is 3 feet around this perimeter.
Right. And that's, I think
same over here.
Panel 17 has been, fairly agreeable, I think, at least in the last few code cycles that I've been involved in. We realize, look, you can't carry this protection of voltage gradients out forever away from the pool. That there's distance limitations where it's going to stop.
Right.
And that stopping point up to 3 foot out from the pool, all based on, someone's step potential away with 1
Cool.
foot in the water and 1 foot away.
Hard pressed to step more than 3 feet.
Yeah. And
So,
reach potentials, those types of things
Yep.
have been determined. 3 foot seems to work. I don't think we received documentation where we need to extend that measure.
and I don't recall anybody trying to push it to 4 feet or 5 feet, or I don't recall any. 3 feet has been pretty consistent. I don't think anybody messed with it.
Well, I messed.
Did you mess with it? You wanted it to be more?
Well,
You didn't
know,
even
again, I don't-
substantiate it. You just wanted it to be more,
I
huh?
don't want to get too much into the history, but we said a TIA changed this, was the driver of changing this language after the 2023 was issued. It was a TIA that brought this not only 3 foot out, the requirement in the NEC about perimeter surfaces was always 3 foot out.
Right.
And that's where the language stopped. But the TIA that came in after the 23
Did
put
that
this,
bring the up and the down?
yeah, it brought the measurement to 3 foot up and 2 foot down.
Oh,
And yeah, I'll take responsibility for putting the PI in that said 3 foot out, 3 foot up, and I think 4 foot, 5 foot down. Or maybe
so
I
they
changed
kept it
both
simple and
measurements.
said 3 feet, 3
Yeah,
feet,
so we
3 feet,
landed
3
on
feet.
3 and 3 and 3.
Keep it simple.
Yeah.
So you were the one that tried to make it difficult. Okay, that's it. There you go. Blame Vince.
Blame it on me. And
Email is at the beginning of the introduction of this video series. So if you want to contact him there you go.
yeah, so I said in another segment, I would let folks know why we left or what time we left in panel meetings one day discussing all of this. And,
Oh yeah.
and that was, again, I'll take credit, not good or bad credit, but I did submit a PI in based on that TIA language to do some cleanup here. I introduced not only 3 out, 3 up, and right, well, it was 2 foot down. I try to increase those up and down measurements.
Right.
After thinking, wow, what if there are steps, different grades of this perimeter surface going around the pool?
Mhm.
When do we hit a point where we're at
3 feet's 3 feet in my mind. So whether I'm going up or I'm going down, it's 3 feet. It's 3 feet. You know, if you want to be out 3 feet, then if it happens to go up 3 feet, going up steps, you still got the same steps as you're stepping out of it. I mean, so or whatnot, or stepping 3 feet, 3 feet. Now, maybe going down, you don't take as wide of a gate or whatever, but you could be reaching over the edge of the pool and hanging out. So again, 3 feet puts us out there just about at maximum arm reach. Again, at the worst case scenario. So
right. And that was my thought. If there's a difference in grade change around the pool and you come out of the pool and go down a few steps and still walk around the pool, well, it's very common for folks to walk and then throw their arms into
right,
hanging out there. You put a beer or something on the ledge of the pool and you throw your arms in.
reach out.
So what's the distance down to provide protection? Should it be more than 3? And I think I did introduce 4 or 5 foot to engage the panel to have the discussion. And again, we landed where we landed, 3 up, 3, 3, and 3. So we'll see how that holds.
Now, looking here, I see this is kind of going over this a little bit, but again, the conductive pay portion, the parameter A, we kind of looked over A, but I wanted to go to this because it kind of throws it in a quick, like a drink from the fire hose scenario.
Yeah, there's more requirements. This is a continuation of the A requirement.
Yeah. So we're not fully embedded in concrete. The copper grid and unencapsulated steel structural welded mesh used for the equipotential bonding shall be listed for corrosion resistance. And again, you brought that up, whether or not that mesh is listed for corrosion resistance or direction in the earth. But it says here, if you're going to use it, it has to be. So we have to assume, I would have to assume that the ASTM A615 or the, A1022 or A1064, all these ASTM standards would have to assume that that's going to give guidance for this type of stuff, right?
Well, it probably does, but I don't think that affects listing.
Yeah, because ASTM is not a listing requirement. Again, we make wire to ASTM, and it's not a requirement.
But you see that there's an effective date associated.
Ah, yes. So we have, and dealing with this and mechanical points, it says the listing requirement shall become effective January 1st. So we're going to give people time to determine whether or not so is that the thought that will create a listing requirement for this mesh? there's a listing requirement for this,
That's the hope.
Yeah.
What this means is this mesh isn't listed for this application. So we're giving industry time to catch up. Now,
so is
whether
it,
they,
so is it equipment? Is it not electrical equipment, is it?
well,
Because if it
that's,
is, we can't use it if it ain't listed, remember?
that's a good point. And the listing language says electrical equipment. In this application, I think you can make the argument, well, it's going to perform an electric function. When using it for this application, I think you can make the argument it is electrical equipment because we're going to use it to perform an electrical function. Bonding. I know that's a,
Well, then that would mean at this point you
can-
can't use it
well,
until
the language is saying,
January 1st.
yeah, we're giving you a buy until January, I think it's January 1st of
Yep,
2029.
2029,
Because that
yep.
listing doesn't exist yet. And in all honesty, I think originally this said January 1st, 2026.
So we moved it.
And now we pushed it in this code cycle out because it hasn't happened yet. And the next code cycle, maybe we're going to push it out again. And ultimately, I don't know, maybe this language disappears, maybe it doesn't, maybe listing actually happens for this, but for now, you can use it. You can use it when not fully embedded in concrete. And it does not have to be listed based on what we have here.
And
It doesn't end there.
no, it doesn't end there. So the copper grid or the unencapsulated steel structural welded wire reinforcement shall also meet the following. So again, as we recap this, if you have rebar that's encapsulated or you don't have structure reinforcing steel, you have the other two options. You have the grid, and then you have the structural, the unencapsulated structural steel welded wire reinforcement like mesh. Okay, you got two choices here. So the conductor grid is constructed of 8-gauge solid copper or 40% copper clad steel and arranged in accordance with 680.26B1B3. That's the 12 by 12,
Correct.
up to a tolerance of 4-inch tolerance.
And if folks are buying this grid from manufacturer, they meet that.
Yeah, I mean, we're not making this thing. You saw a picture earlier of it in a roll. Nobody's making this thing. Who's going to make all those connections? Who wants to exothermic weld all those connections? Who wants split bolts at all this connections? Who would in their right mind has got the time to sit there and do that? No, I'm not gonna waste my time. You're buying this already pre-made. Number two, if it's a structure steel welded wire reinforcement, is a minimum ASTM 6x6 W 2.0. I'm not sure what that all means. Is that an actual ASTM standard, or is that just the size? I don't know.
I don't think that's a call out to a particular ASTM standard, I don't think, but it does call out some size out.
Yeah, I mean, it says ASTM 6x6 W 2.0 times W 2.0. Okay.
I think that puts it very close to, if not exactly the size of an 8-gauge wire, 8-gauge copper wire.
Okay.
I think the pattern will be close to that 12 by 12, 16 by 16 4-inch tolerance.
Well, it also says that or minimum number 3 rebar constructed in a 12-inch grid. So, is this saying now that I could actually lay out individual portions of rebar horizontally, I mean, perpendicular to each other and make sure that they're 12 by 12? No tolerance here, 12 by 12, and connect all these together. So I'm actually going to be creating by laying rebar all the way around and then running perpendicular rebar all the way around, making my own. It's not the structural steel. We're just using number 3 rebar, minimum 3 rebar, and it's got to be 12-inch grid all the way around if we wanted to do that.
Yeah, I think that's what it's saying. Although I think it, for that piece of it, it needs a little restructure in the language because all of a sudden rebar is coming in the middle of these requirements.
Yeah, I mean, it was what? It was
no
welded
language.
reinforcement, and it was talking about copper grid. Now all of a sudden it's going to interject the ability to use or number 3 rebar connected in a 12-inch grid. So it's basically a third option
mixed in here.
Mixed, just thrown in, sprinkled in.
So again, it's not perfection.
The hell happened? Dude,
And,
what happened? Coat panel, freaking hell, went crazy. They went crazy, trying to. That should be another. That should be another option to be able to
I
do the
think so.
rebar. Again, I'm going to tell you, I ain't wasting my time laying out rebar pieces 3 feet long, and then have pieces put again. So it'd be 3 feet, and then have two of them 12 inches in, one 12 inches, another one all the way around the sprinter. And then I'd have to physically tie each one of the 3 foot pieces that come out from the pool to the one that's going perpendicular with it all the way around. No way.
Mhm.
Not me. I'm not
It's an
going to do
option.
that. Yeah, it's an option, but I'm like, dude, just give me that welded wire reinforcing mesh. Roll that sucker around and done.
Yeah, I would think so.
Yeah. At least it's giving you another option. What are the odds that in the 2029 this comes back as a third option, or
It very well. I mean,
the rebar?
if I feel really invigorated, maybe I do a PI to clean it up, but I can't guarantee that I'm going to be putting one in on that.
All right, so it says the copper grid and steel structural welded wire reinforcement following the contour of the perimeter surface, extending not less again 3 feet horizontal beyond the inside wall of the pool. So making its way all the way around.
I
Yeah.
think we forgot to mention, I said I was going to mention it. Discussions about this
Yeah.
in phase in. I think this was the first draft. So we met, I think, in Myrtle Beach
Okay.
for first draft meetings as panel 17, discussing this and massaging this language,
26.
2026 language in the first draft. You bailed out. You were out.
Shh.
You slacker. But a bunch of us, panel 17 members, we left the room.
They'll say this is one of those task meetings where they come together after the meeting, and you're supposed to be so dedicated that after you spent all day looking at code in a room, that you're going to stick around for the next 4, 5, 6 hours with a bunch of guys continuing to argue something. Sorry, I checked out.
It was a discussion. It was not an argument.
Okay, so it's a
but
discussion.
We left the meeting room. It was 9:30 or 10 o'clock that night after starting at 8 o'clock in the morning. So we had a long day that day. And I don't say that to be, oh, I'm such a dedicated. I'm just saying.
See the
we-
time,
we-
folks, that people put into this code.
We talked about it before. It's changes, usually not by lack of discussion. And we spent a lot of time discussing how to restructure this to make it more readable. And again, we just saw not perfection, but hopefully it's easier for people to maneuver through the requirements here. But again, if anybody sees room for improvement, submit.
And subtle takeaway again, keep reminding you, you do not see the option for an 8 gauge single conductor running around the perimeter of the pool with this conductive paved portion.
Correct.
Still don't see it. Still don't see it. All right. And again, so it's again measured, again, 3 foot out from the inside of it. Okay. Now, what about now we have unpaved portions of the perimeter? Okay. So shall be bonded with any of the following methods. Number one, conductors shall meet the following. Okay, so unpaved portions. So it says at least one minimum 8 gauge bare solid. And this is funny, real quick. So we're getting ready to read this, okay? And you've heard me say that the single 8 gauge has gone away. And I'm going to read this, and this is going to sound very much like the 8 gauge single conductor is still there. And you're going to like, oh yeah, I still can run that single 8 around there, and boom, I don't have to do all that crap with the grids and whatever. It's what it's going to feel like, but I'm going to get you to a point where we're going to go, womp, womp, womp.
Yeah, your hopes and dreams are going to be crushed.
They're going to be crushed.
We're gonna. It's the big tease, and then your hopes and dreams will be crushed, unfortunately.
So again, remember, first thing we're talking about is unpaved.
Right. So like
this is grass, this is dirt, this is, this is not a conductive paved surface.
Right. So we already saw the single 8 gauge, not an option for the paved.
The paved.
Now we move to unpaved portions, like you said, grass or dirt. Okay, now what are our options to jam in the grass or the dirt to make a connection to? So let's see what it tells us. says a wire or
Okay.
conductor.
Conductor
Great.
shall meet the following. Number one, it says at least one minimum 8 AWG bare solid conductor or a 40% copper clad steel conductor is provided, including the 8 AWG equipotential bonding conductor if available. Okay. I'm not sure how that flows, but okay, basically 1/8 AWG bare, okay, minimum.
And I don't, not to make it more confusing, but I think that reference, the second reference, 8 gauge equipotential bonding conductor, if available, I think that's what we spoke about previously when it said you can connect, you're permitted to connect pieces of the list items, like I had mentioned, the metal frame of the door to the metal
Right.
fence. The
Right.
metal frame is all the way over there. The metal fence is all the way at that side of the pool.
Mm-hmm.
We're permitted to connect those with an 8 gauge. We're permitted to run that 8 gauge in the perimeter surface,
Right.
but that 8 gauge connecting those two pieces is not the perimeter surface equipotential bonding.
And that's
I
probably
think
why it also says equipotential bonding conductor. We're not talking about the grid at
that's
this point.
correct.
It's the equipotential bonding conductor if it's available.
Right.
That type of thing.
So I think that's what that language is trying to capture. This 8 gauge that might be connecting lots of pieces, but it happens to be laying in the perimeter surface because that's the shortest point from over there to
Right.
over there.
And that's why it says including the
Right.
8. Okay, so we got that. So it's sounding good for the folks that like the single conductor so far.
So far, it sounds good.
B, it says the conductors follow the contour of the perimeter surface. No difference where it used to be.
Yep.
Next one, the conductor is 18 to 24 inches from the inside wall of the pool. So as you go away from the pool, no less than 18, no more than 24 inches around the perimeter of the pool.
Had that language.
Had that before. That's not new. Sorry about that, folks. My mouse goes away. All right. D, it says the conductor is under the unpaved portion of the perimeter surface, 4 to 6 inches below the finished grade. So we're digging down 4 to 6 inches under the unpaved perimeter surface,
Right.
getting it down in the dirt, getting it in the dirt or down in the unpaved surface, right? And then we get to what? Oops, the
Get
last
to
one
the
here.
language that's going to collapse.
Yeah, right here. It says E. It says the conductors is installed only in perimeter surfaces not intended to have direct access to swimming in the pool. Womp, womp, womp. Okay. So I'm going to tell you what I think that we could do with this, and tell me if you agree, Vince. So I'm thinking that we could have all the area of the pool could have this grid that we've been talking about, installed, right? In the unpaved surface. We could have an option to have the grid. We could have an option to have rebar. We could have a lot of options, right, around it. But you could have a portion around it that wouldn't facilitate that, and it's not an area where you would directly access the swimming pool. Maybe it's running around the side where there's a 20 inches and there's a wall there, and you need to get around that's right.
Mm-hmm.
So I could probably on that portion I could run a single 8 around that portion. That's not where people are going to be stepping out of it. There's not that potential like we talked about stepping out 3 feet. It's not there. So if that's the case, it doesn't provide direct access to the pool, then I could use the 8.
I would agree. Or, you have other scenarios. Again, if we do a nice, simple, got a square pool, 3 sides, direct access, people, you can jump in and out of there.
Yeah.
There's nothing. But the 4th side, someone does some hardscaping,
Rocky,
and trees and all these things. And
the perimeter rule is not removed.
Still have a perimeter surface there, but really, you have to climb over rocks and other things to actually get into the pool. Well, it's really not designed. That's not an area designed for people to have direct access. So what this language is saying is in that 4th side where all this rock garden is or whatever it is, maybe there's a little waterfall feature or something like that.
Mm-hmm.
Well, in that 4th side, you can put the single 8 gauge
Yeah.
in that portion. But when you get to the, sides 1 and 2,
Mhm.
well, you're going to have to connect that 8 gauge to one of those
one of the
other
other methods we're going to
options,
look at in a minute.
like
Yeah.
the
Grid.
wire or the grid,
Yeah.
and then in all those other areas that have direct access to swimmers, 8 gauge single, 8 gauge. Not an option like we just saw. You're gonna have to go with uh, the wire mesh,
Oh, we haven't gotten there.
structural wire mesh, or
Yeah,
we
what are the
haven't
other
gotten there.
options?
I thought
Let's
we just looked at the other.
no, for unpaid portion, we're gonna have there's an item 2.
Okay, so let's see
Look
what
at
that
that.
is.
So we'll see what you have to use. But again, you made a great point. As we've been saying, folks, the way you've done it in the past with the single 8 for the most of the pools you're going to deal with, gone.
Yeah, really.
Not going to be an option anymore. And how did this get here? There was a lot of testing done, submitted to the code panel. I think, what is it? EPRI? There was a lot of testing. They brought back data. Next cycle brought back medium door. And it just shows you. And if you think about the common sense approach to it, surface area alone. Single conductor in the earth does not have the same amount of surface areas that you're going to get collectively like you would get from a mesh or from a grid. Okay. And that's what we're trying to do, right? We're trying to bring everything up relevant to from the water, from the pool to the perimeter surface, everything up to the same potential. Again, voltage that may be in the water due to however it's constructed, it may get into the water through some other means, a neighbor, a concentric neutral that's failing on a utility that's in the ground nearby, or maybe improper case to neutral connections you're making in your system, or whatever you're doing. We're not going to get rid of that, but we can bring the perimeter up to so that you do not have a what is it, feelable, I guess, is that it? There's a noticeable difference of potential or voltage gradients that is extreme. And a single wire, I mean, we've done it for years, but I have a hard pressed understanding on where it came from and how that could have given us enough surface area in the earth to do the same. We're required to do the grid. We need it. We're required to do these other things. I just don't know where the single wire came from, that type of thing.
And we just have to, folks just have to accept, and you don't have to like it.
No.
You just have to accept this is where we are in the 2026. This is where we are in the 2023 NEC. That if your area recognizes the TIA that brought this language in, or changed the language in 2023, and that premise of the TIA has held true for the 2026. That's what the premise of these changes are. So yeah, it's here. It's in here. This is what we're dealing with. So you just have to understand what your options are. Again, you don't have to like it, but you do have to accept that that's where we are. It's the reality.
And so then that moves us into, well, if you can't do that and you can't meet all of those items, right? Because you have to meet the following, you have to meet all of them, not any one of them. You got to meet all of them.
Oh, I see a typo on my slide.
You have a typo on your slide?
Yeah, I think for list item 2 there, it should be just CU, copper, or
Okay.
believe, but you can double check the.
Yeah, well, number 2, you might have left off a T. I don't know. All right, so at the end of the day, unpaid portions of the perimeter surface shall be bonded. So we'll go look at the NEC because, who knows? So here it is over here. Oh, no, by the way, folks, we didn't make this up. There is E right there. That's the womp, womp, womp when it comes to using the single conductor right there. If you can't get past E, then you just can't use it, okay? That type of thing, except for in these applications. Now, here's the second one. It says a copper, okay? A copper or 40% copper clad steel conductor, grid, or unencapsulated steel structural welded wire reinforcing mesh, as we'll call it, used for equipotential bonding of the unpaved portion of the perimeter surface shall meet the following. Okay, so do this. So it is installed in accordance with 680.26B2A. Okay, and again, if we tap that, here you see we're talking about unencapsulated. There's the grid, and that's the mesh. So it's got to meet all that, right? And sure where it jumped to. Let's go back. So it's got to meet that. So it's got to be installed in accordance with 680.26B2A. B, it says if it is located within an unpaved surface between 4 to 6 inches below the finished grade. Now, Vince, didn't we already figure that we were going to do that anyway? I mean, this is for the unpaved.
This is for the unpaved.
In the paved one up here, it was kind of the same deal, right?
4 to 6 inches
Yeah.
below.
Well, this one is 6 inches, right? So it's not more than 6. So it could have been 4, but it's not more than 6. Here, essentially saying install it essentially the same way, but it needs to be specifically installed from between 4 to 6 inches below grade. So in this case here, and I would think because it's an unpaved surface, you have no protection like that type of thing. So again, they want it to be at least 4 inches down and no more than 6 inches down.
So if we recap, what are your options for the unpaved portion? We just saw it's a wire.
Wire, if you met all these caveats.
If you met all those caveats, so the single wire, really, your only option to use it is in those areas that don't provide direct access. Cool.
Right.
So if it's not that, what's your other option than unpaved? That was
The same as we've been.
that was
We're
the
gonna do
copper grid.
the grid or the wire mesh.
Where does it? Let's have that language again.
Yep.
To see the wire mesh.
Right
Okay.
here.
So we can use the wire.
Or unencapsulated steel structural welded wire reinforcing. That's what I'm saying. Mesh.
Okay.
Mesh.
So it could be the wire, but really it's not the single weight. Very limited pieces of that.
Yep.
Could be the copper.
So you're going to be doing
grid.
you're going to be doing your grid or your concrete.
Or it's unencapsulated steel welded wire reinforcement. And again, we're in an unpaved area.
Mm-hmm.
So again, I would caution folks to say, man, you probably need to talk to your inspector, your AHJ, because if you're going to put this welded wire reinforcement in direct contact with the earth, what are they going to approve? Is it just, like I said before?
Are they going to say, is it got to be a galvanized?
Right, the highly technical, regular, schmegular, the stuff that would go in the concrete? Or are they going to lean to say, no, you need to get stainless steel, you need to get some kind of hot dip galvanized one? So I just caution folks, have that conversation ahead of time.
Yeah, because you're right. This is not telling you.
It's not telling
Even
us.
educational note about the different ASTM standards, this is not telling you that, oh, this steel welded wire. I mean, typically the ones we've seen, it's designed to go into the concrete.
Right.
So yeah.
Just caution folks with that. Just to see how you're going to maneuver. Nobody wants to install twice. That's for sure.
That's right. We get paid to do it once. We don't get paid to do it twice. At least most of us. And I think one other one, I think I saw it was out of place. Let me go back to this. Let's see. I think it was.
Let me take a drink of vodka. I moved to vodka since we're dealing with the perimeter surface.
Mm-hmm. Oh, we knew that this was going to be a separate one that was going to have to deal with. Okay. All right. So real quick, let's go to the NEC then real quick on this one then. So again, so we've covered these two. Okay. Ooh. So that's very, very important to realize. Paved and unpaved. All right. What about C? Non-conductive perimeter surfaces. Okay. What are we talking about? Wood, plastic, Trek board, Trek, all those non-conductive perimeter surfaces, right?
So how do you, and that was always a question too. I mean, I received that question dozens of times over the years. What do we do? Are we supposed to?
We're supposed to, what do we staple it underneath the deck boards?
8 gauge and staple it underneath there. And the code really never gave us guidance on that. But now, as part of that TIA that came free, and that language has been brought over here to 2026, we have some kind of guidance. So let's see what it tells us.
All right, so the code says for those non-conductive perimeter surfaces, it says equipotential bonding shall not be required for non-conductive portions of perimeter surface that are separated from earth or raised on non-conducting supports. Okay, so I guess if you have a non-conductive perimeter, but it is on the earth. Okay, because the way this says perimeters that are separated from the earth. Okay, so I guess it's not in the earth. So what's separated? Sitting on top of it?
I
Is that okay?
I would
I'm sure I
say
learned this
it's
language, but
elevated above
well, the next one says or raised
on non-conducting
supports.
support. So I know that non-conducting supports,
Wood.
it would be wood, or I know a couple of years ago, probably 5 years ago, I received a call from an AHJ, I think Chicago area, and he was describing this pool that was at a hotel. The pool was up on a higher floor of the hotel,
Okay.
or up on the roof maybe. And the question was, they formed the pool. The actual perimeter surface where folks would be walking around the pool was raised up.
That makes sense. Even if it was,
uh,
we have to address that because if you have a pool that is now a pool can be on a building, it is separated. If it's a non-conductive perimeter, it is separated from earth.
right.
So I would not. What do I need a equipotential bond for?
Right. And that was his question. And, you know, 5, 6, 7 years ago, whenever I got the call, we didn't have any of this language to kind of help him maneuver through this.
That dude, take a 8 gauge all the way down to the earth.
Yeah, from the 30th
It's on
floor
the
of
30th floor. Just take it all the way down.
So this language is saying if it's, what was it, separated again?
Yeah.
Let's look at it again.
Oops, right here.
Said
It says, shall not be required for non-conductive portions of a perimeter surface that are separated from earth. Okay. So again, when I think separated, I mean not in the earth, it's totally separated from it. Or raised on non-conducting supports.
So whatever that non-conducting support. So to your point, I think, you know, if we thought of a pool that's more closer to grade level, but I jam a 2x4, 2x6 vertically into the earth,
That's a non-conductive support.
right? That's a non-conductive support. So the dirt is at this level, but my decking is a couple inches below, above that. So there's an air gap between maybe the grass or the dirt or grade where my non-conductive.
Yeah. Then what's
perimeter
then at that point,
surfaces.
why would I need to have a?
So this language is telling me, so far I'm reading that not to do any equipotential bonding.
And that's good because in the past we didn't have that guidance, and people would have said, well, even though that you have a deck, for example, or you have something up or a perimeter around it, oh, I'm going to need you to put it in the ground down there, serving zero purpose in the ground because you're not going to be stepping from the pool onto the earth or onto a conductive surface. You're going to be stepping onto a non-conductive perimeter surface if that's what you've got.
But let's look at the second sentence and see what that says. But we're going to come back to this. I want to come back to the language that we just talked about. With
now, the second sentence seems like it's a redundancy of the first. So it says, equipotential bonding shall not be required for any perimeter surface that is electrically separated from the pool structure, okay, and raised on non-conductive supports above an equipotentially bonded surface. Okay. All right. Explain that one to me.
I don't have honestly a good explanation for it. And you know, I'll also say so this was also language that was brought in as part of that TIA that came in after the 3. And I did speak to some of those folks who were on the task group that crafted this language. Some members were Panel 17 members. Some were not Panel 17 members. They were folks inside the pool industry. I wasn't asked to be on the task group. I don't think we were asked to be on the task group that brought this TIA language forward, and that's okay. But I did talk to a few of those folks who were on the task group, and one of the questions I had was, what does this language mean about this electrically separated? And I can honestly say, after they explained it to me, I still didn't understand. I think that, again, it proves what we spoke about a couple of times already, but you mentioned it. Yeah, just because we're on a panel, whatever panel we happen to be on, this one happens to be on 17, doesn't mean we totally understand or can explain every single, because I don't have a good explanation of what that
Well, the only thing
literally means.
that I can think when it's electrically separated is that you have uh, there is no connection between it. So I have the um, perimeter surface, and it is uh, nothing electrical involved in it, nothing running to it, nothing in it, and it's totally separated from another surface that may have some electrical connection or something to it. I mean, they're electrically separated,
Mhm.
whatever that means. I think the last part of it's probably, though I get it, is where it says and raised on a non-conductor support above an equipotentially bonded surface. So this could be where you have a bonded surface part of within 5 feet or some kind. Maybe it's a metal decking and it's within 5 feet and it's bonded to the equipotential bonding grid. But now the pool is raised or it's up on a non-conductive platform above it. And so underneath it, it may be equipotentially bonded surface, but you have now a non-conductor surface that's above it,
Separation.
separation. And in that scenario is it's like, dude, don't worry about it. Okay. I mean, it's yes, it may be underneath it. And I, again, I can't think of whatever reason it may be, except for maybe there is a metal flooring or a metal base
Mhm.
or something, and that would be within 5 feet. So it is bonded to the equipotential bonding grid already, but now we're building a non-conductive surface that's raised above it that the pool may sit on. And if that's the point, it's saying, look, it's still non-conductive. I think the moral of the story is if it's a non-conductive perimeter surface, you don't have to do the equipotential bonding for that.
Okay, so yeah, and I want to talk more about that because the more I'm reconnecting. So I want to make sure you're seeing everything at your end,
Yep.
correct? Okay. So let
Yep. Still seeing.
I may have to log out and log back in, but that's okay. I want to talk more about this though, what the requirement, the language is telling us this non-conductive material
Mhm.
would, like we said, or is it this fiber?
Trek decking,
Trek.
plastic, one of those type of decking.
So, and I'm going to basically ask you this. I'm asking the question. My interpretation of this is okay. If we go back to the scenario where we've got a permanently installed pool, it's more towards grade level, closer
Yeah.
to grade level,
Yeah.
and folks do a non-conductive deck
Around it.
that, right? But something supports that non-conductive deck, correct? There is earth down there
Underneath
below it.
Underneath it.
Let's say they leave, some kind of air gap. So
Or maybe not. Maybe maybe they make this kind of like teak wood decking or whatever that wraps around the pool. Maybe it sits right on the grading. Maybe it sits right on the earth. Maybe it sits right on crushed gravel. Maybe it sits on something.
So here's my question.
Yeah.
That this requirement is saying, okay, that material, that non-conductive material, does not require equipotential bonding.
Mm-hmm.
But I think this is also saying something's underneath that, holding it up, supporting it.
Right.
If it is whatever that is, if it's within the 3 foot out, 3 foot up, 3 foot down dimension, it's in the perimeter surface sphere, equipotential bonding is going to be required underneath that non-conductive decking, whatever is holding it up. If that whatever is down there falls within the 3 foot down, 3 foot down.
I think I'm torn because I don't know that it does. Because the paved is A, unpaved is B, and C is a standalone. It's a non-conductive perimeter.
So
Period.
Let's look at that language again and see. And I'm going to see if I could buy into that.
Yeah. So here we're at in the code, and you can refresh if you need to.
Yep.
Reload.
No, I did. It came back up.
Okay. So A right here, so the whole charging here is the perimeter surface, and it says that it's provided, it's specified in A, B, and C, right? And then it talks about the 3 feet, yada, 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 right? Provided as specified. Then we go down to A. And again, for the 3 feet, it's saying that in the conductive pay portion, it's telling you what you can use, right? All of that type of thing. How you doing? Get down to B, unpaved portion. Okay? I'm with you though. The 3 feet still 3 feet. The problem with that is you get down here to the single conductor. It has nothing to. This option has nothing to do with the 3 feet. Um, it's 18 to 24 inches out with the single. If you meet all these caveats, probably not going to happen, right? So you're going to end up being at this option, right? And this is going to tell us that it should be installed in accordance with B2A. So that would be B2A, right? Right? Same way. Okay. But it's also, if you, for example, if it's an unpaved surface, it's got to be installed within the 4 to 6 inches. Okay. And then you get down to C, which seems to be it's a standalone, and it's point blank saying that equipotential bonding shall not be required for non-conductive portions of perimeter surfaces. That's what we're talking about, right? Perimeter surface that are separated from earth or raised on a non-conductive support.
So if we stop right there in your example, said, well, this decking material, never call it.
It's not in the earth, so it's separated from the earth, guys. Yeah.
No, you said it's sitting right on.
It's sitting on it, but it's separated from the earth. It's not in the earth. It's not one with the earth. It's 2 pieces side by side. They're separated.
But it's sitting on the earth.
Okay.
Then it's not separated. It's touching the
It didn't say touching. It says separate. It's the earth, right? It's the earth. Now that was my example. So the same question to you be: what if they put gravel around it? Is it separated from the earth? Because the earth is the earth. The gravel is a build material.
Something on top of the
Something on
earth.
top of it.
Yeah. So I
Is
just,
it separated there?
I'm not,
I guess the point
I'm
is, why
unsure
does it
about this one.
say? What would be the point? We talked about this. What would be the point of putting an equipotential bonding grid around it if you can't contact
Touch
the
it.
earth?
Yeah.
If what would be the point? If you can't, I mean, we're back to that thing with, do we tack something underneath the wood deck?
Mhm.
It's pointless. The whole purpose was if I have a non-conductive perimeter surface running around it and I take it at face value, it's non-conductive, right? And we're not talking about something that somebody would slide up to it and they move away, this portable, there's earth underneath it. Ooh, you're just putting these little mats or whatever you want to put around it. No, we're talking about if it is truly a non-conductive perimeter surface around it, then it flat point blank says that it shall not be required for a non-conductive portion. So I guess what you're saying is, well, if it's not that and it's earth, doesn't that fall under the unpaved portion? And the unpaved portion says, okay, I'm gonna use a grid, but I think that would kind of defeat the purpose.
I don't think it's no, I don't think I'm trying to say it's pointing me back to the unpaved. Just, since I'm not 100% buying in on the language here, because I still didn't get a good explanation of all this electrically separated language that came in here. I just want to, as best I can, understand what the requirement says. so
Okay,
we can share
I'm going to
with
make your life easier for everybody out there watching. You ready? Everybody's life is. Go back to the code right here. I think that because this is an A that's requiring, and I think it's just kind of like it, the same nature when it comes to a vinyl pool or a fiberglass pool where it says not a conductive pool shell. Done. You don't have to do the conductive pool shell. I think here you've got either a conductive surface and you have a non-conductive
Conductive
portion, and I think you're given an option C that says, you know what? If it's a non-conductive perimeter surface, it says the equipotential bonding shall not be required for non-conductive portions of perimeter surfaces that are separated from the earth. So they're not in the earth. I'm going to say they're separated from the earth. So at some point something has to stop, right? The wood goes down to the earth, stops. The earth continues on. They are separate. Okay, they're not one. Okay, they're not be the earth, Danielson. So I think that's where we're at with that. Or they're raised on a non-conducting supports, because at the end of the day, I think what I have to pull back to is that raised up, it's telling you I don't have to bond it. I don't
Mhm.
have to have equipotential. If it's wood or non-conductive material sitting on it, it's also saying I don't have to bond it. So I would say for lack of other direction, and this is fairly new right here, I would say for lack of direction, if I had a true non-conductive perimeter surface that goes out up the 3 feet out around the perimeter, because that's the area we're talking about, that if it is truly non-conductive perimeter surface, I'm not going to do squat.
Okay.
Okay. I'm not now. This is be tough for an inspector because I can see somebody saying, yeah, what we're going to do is it's grass around it, it's dirt around it. And what we're going to do now is after that, we're just going to bring in some wood and build a little. But that's no different than building a deck around a pool, right? See any difference? Difference, a deck is probably going to be raised. So that covers that. But that's why it says here, it says separated from the earth. So it's not in the earth. It's maybe sitting on it, but it's not in the earth. So it is technically separated from the earth. Or what if it's raised above the earth on a decking system or something like that? Then I think it also is to remind us, dude, don't go trying to put a daggone equipotential bonding grid in the ground underneath a deck, plastic deck. And the reason I say that is because the informational note reminds us of what non-conducting materials are, not limited to wood, plastic, composite, fiberglass, whatever. So I think until we get additional direction, again, it's up to the AHJ, but I'm going to think if this pool is designed with a, a non-conductive perimeter surface, could be as fancy as teak wood, could be as fancy as Trek board, whatever it is. Um, you know, I think your fear and some people's fear was somebody's going to design it this way so they don't have to do an equipotential bonding grid. And then all of a sudden, what happens if that deck board rots away or that deck board deteriorates or get damaged and they say, oh crap, I'm going to take it up. And now I'm down to dirt or I'm down to whatever. Now there is nothing. So I think that unfortunately the code is not the is it's for it's not the expective inspection code. It's
Correct.
inspection code.
Correct.
So I think if it's a non-conductor perimeter surface, I think the argument, since it's been added in here now,
Mhm.
never was an issue in the past. Now it's added in here that I think it's openly saying, look, if the perimeter is non-conductive, you don't need to do the
Okay.
potential binding. That would be the way I would take it until we get additional clarification.
All right. I think we beat that one up.
Beat
But
it
hey,
to
I
death.
was looking at this. You have the same concerns that I do. Quite 100% behind in that language. Submit a PI because I can tell you what, panel 17 is tired of arguing my PIs. I put them in. They look at me like, oh God, he put another one. Now we're going to be here till 10 o'clock again.
What is this
So,
guy doing with the damn surfaces? He's done with this.
yeah, well, I always look at through the lens more. I represent, like I said, I represent EMA on both these co-makers. I kind of skew. I look through the lens of an AHJ and installer more when I read this language. I'm trying to say, is this really clear, as clear as we can make it from an enforcement standpoint, and so installers know what's expected of them. And that's why I kind of say I'm like wishy-washy on some of this stuff.
I think I
but
think that language, Vince, is just simply decking.
it's crystal clear.
I think it's a
All right.
simply
Well,
non. I just think it's
man up.
wood, plastic, Trek deck. I think that's
Mhm.
just in order to keep us from having to put a daggone equipotential underneath, in the ground or in the earth underneath it when it's a non-conductive surface and you're building it around a deck, in a deck, any of that type of thing that might come into, then I think this gives the option to say, look, it's not why.
Right.
And now I can't fix it if somebody comes and rips that up later. Okay, well,
Mhm.
good. Guess what? Your local jurisdiction has the ability to come back and do follow-up inspections, and they can come back now under 680.4, was it? And say, oh, guess what? You now have to have an equipotential bonding grid. And guess what, folks? Well, if it is unpaved, if it is dirt, then okay, so you're just going to dig it up and put a grid around it, right? Right? That type of thing. Be done with it. But I also think what it also means is somebody could be building, you could have a deck that may be concrete that may have an established equipotential bonding grid on it, already in it. and then somebody comes in and builds a deck on top of it, and now it's saying, what do I have to do now? Because that one's now underneath it. It's not where I'm going to step out of the pool. So that's what I think that when it talks about, you may have a design where somebody takes a deck and then they decide to a concrete decking around it, and they decide to build a wood or composite around it that is now, and you're saying, well, wait a minute, you're stepping from the pool onto this. Yes, it might be an equipotential bonding grid underneath it in the concrete originally. It may be there already, but now it's not technically because you're stepping out onto the decking. It's fine. It's okay. Okay.
And it makes sense.
All right. Next one, it says, okay, we're getting into the bonding parts, and we're in B3 now.
Yes, we've left the perimeter surface.
We've left.
Right.
Yes. Right.
All right, it's a piece of cake.
No, actually,
Ah,
we're not. It's 680.26 B3. I think this is still, is it still the perimeter?
we're in 3. We've
Hold on,
we're
is it,
moving
is it,
into
is it,
something else.
is it, hold on.
B2 is all the perimeter surface.
Yeah. Okay. Are you, the reason I say that is, okay, yeah, good. So we left the perimeter surface finally. So what is the main takeaway? What did we learn that's the main thing for you folks out there? Paved surface, unpaved surface, non-conductive surface, can go whatever your opinion would be on that one. You go without one, I guess you get a good argument either way. But when it's paved or unpaved, grass versus pavers or concrete pour, one takeaway is you cannot use the single 8 gauge anymore around the perimeter. You can do it for the small connecting portion that does not, that you don't have direct access to the pool, but everywhere else that you would be able to go straight into the pool, you can't use that 8 gauge single conductor anymore. That should be your biggest takeaway. It's gone. Okay.
Yeah, and I think, that certainly the perimeter surface length is one piece of 680 where you really have to read and reread it to really get your arms around it.
I mean, look
Most
at
of the
us.
other
We're 2
equipment-
hours and 11 minutes into
Yeah,
the equipotential bonding grid, and we were really spent the vast majority of that time on the perimeter. And I told him before we started, I told him that I said, dude, be easy. We'll blow right by that one. And that, it's we won't go into the past. We'll just tell you what the future is. But you can see there's a lot of things to think about. And I'm gonna be honest with you guys. Down in the comments, if you experience your opinions, they do help because it allows us to take back things. We'll put in public inputs. We'll do it. You can do it, and do this kind of stuff. So
yep. And I mentioned I present on this topic a lot at IAI meetings across the country, and normally, honestly, it takes 2 hours
just
to go
talk
through
about
the
this one.
680-26, just the equipotential part 1 and part 2, what we just looked at, the
Yep.
shell versus the perimeter surface. It normally runs an hour and 45 to 2
get through
hours.
it.
So we're right on
We're right on the normal discussion.
because we've asked ourselves the same questions that I would typically get asked as we maneuver through. What about this installation?
Yep.
What about that?
And I
That's
think
just
it's
the
great. This is
reality of it.
why, folks, in these videos, I'm allowing these discussions and it alone because one, it's again, people may say out there and say, boy, y'all talk. I have to say, you have to be a fly in the room because here we are, 2 people that serve on these code panels. And sometimes we have to look at this language, and sometimes we're not taking as detailed look as we are when we're sitting here. When we're doing code development or in those meetings, we're looking over things. And sometimes when you go back and look at things like this later in retrospect, you go, could we have said something a little different? Maybe we were tired at the code panel. Vince has kept us up till 8, 9, and 10 o'clock at night. We're like, just fine.
Sorry.
That's
Yeah.
fine. We'll do it live. So
Just make it 3 foot by 3 by 3 and let's get on with this.
make it over with and let's go. All right. So the next one that we're dealing with here is 680.26B3. And this is again still talking about equipotential, but we're getting to another thing that's a part of the equipotential bonding grid. And this is bonding of parts to metallic components. All right, look at this pool. So this pool right here, now this might get a vinyl liner.
Absolutely.
This is not going to be a conductive pool shell, but it does have the metal parts, obviously within 5 feet going all around it, right?
So, yeah, I mean, obviously it is a conductive shell. It just doesn't fit into the shell language.
The language of the shell.
But so you could say, well, okay, let's give that up. It doesn't fit in there. Okay. But it's certainly metal within 5 foot.
It
of the pool.
certainly is.
So, you know, no matter what you say, this has to be bonded. I think the next question associated with these types of pools is,
Do I have to bond every section?
exactly,
Every
and
little
I
piece?
get that question, and I've talked to folks about that. And I honestly, I've asked, I haven't taken the time to go do the research. I've I've kind of give guidance to say, well, go look at the manufacturer's installation instructions.
I
See if
think
there's any-
these pieces are bolted together, and
They
I
are.
think that they act as one piece when finally completed.
You would think so.
You would think so. Now, is there anything that's introduced into this that is maybe fiberglass that would break up the connection? Let's just say if I was given an example on this side, there was something here that would break this. So if I made a bond connection here, this is all bolted together, I'm good. But if there was something on this side, for example, that created a separation between this half and this half, then I think that I would have to bond each
Mhm.
one. But
would
I
agree.
think with these also, the manufacturers, I can't remember 100%, but I want to think that these come with lugs down here in the framing in order to make a connection to. I can't remember exactly how these, but I do know they're bolted together. Each piece is bolted together. So I think that when they're bolted together, no different than when you have structural steel in a building, that you're allowed to the framing of the building, all bolted together, right? That type of thing. So, I mean, same concept. I think here, everything is bolted together. But a key takeaway here is that this is metal and this is within 5 feet. Okay.
Yep, bring your
It's-
pointer up to.
Yep.
I know you're
Oops.
pointing.
Yeah. So right here,
Yep.
all of this metal here.
Yeah, and again, for folks watching this, you know, if you install these, or dealt with them, and you have installation instructions, I'm lazy now. I'm gonna go search them. I want this information to be supplied to me. I do enough research on so many other things. I'd love to see installation instructions that actually say, you know, just make one connection to me from
Yep.
the manufacturer, from that.
And I'm going to bolt the rest of these bolted together.
Yeah,
Done.
and that's or maybe it doesn't. Maybe there's instructions say no, you have to make an attachment to every panel. I mean, I hope they don't say that
Right.
from the installation standpoint. But so again, if you have information, share it. I'd love to read through.
And by the way, this is this all this around here, all this does constitute a structural member. Okay, this is all structural to the way this pull. Not the same as what we would have in rebar and other stuff like that, right? And I think B1A is talking about where you might have the structural reinforcing steel. That type of, not that. But again, as it says, and if I go into the code here, just to go over into it, we're right here, and the same thing you have on the slide. It was all metal parts of the pool structure, including reinforcing metal not addressed in 680.26B1A, which is all of that metal is not addressed.
Well, the metal in the picture, just like that,
Yeah.
does not fall in the B1 little a
Yeah.
line.
Does not fall in it, but it shall be bonded, as it says right here.
Right. So this is the fail safe to capture this type of construction.
And it gets where reinforcing steel is encapsulated with a non-conductive compound, the reinforcing steel shall not be required to be bonded. So in this, so I guess, Vince, if this was, I don't know that they come this way, but what is it? If you were to get this, it is actually all, what would that be? If it's all encapsulated, then you wouldn't have to bond any of it?
But we'd have to, we're reinforcing steel. I mean, that
Yeah, but
it
this
sounds
is
like
not this
rebar.
sounds like rebar, but it makes it clear here that it's the including reinforcing steel not addressed in 680.26B1A, which this would not be any of that. Then it goes on to say we're reinforcing steel is encapsulated with a. So why would it be making a reference to if we think that's rebar? Why would it be making any reference? I'm thinking this framing that we have here, right? If it lets me do it right here, all of this, if this was encapsulated, and I don't know that it ever would be, but if it's encapsulated, then just like with the rebar that's encapsulated, right? Then at that point, and again, we don't have to worry about conductive pull shell because it's not, doesn't fall into that.
Right.
But I would think that it's basically saying I wouldn't have to bond any of that either.
Right.
But
Or
I don't think I've ever, that's a lot of
I don't,
covering. That looks
yeah,
just
I
all
don't know if
metal.
you would see that or not. I guess we can also do a what if, if we had this, but we see the kind of those outriggers, those feet
Yeah.
that provide support. If those were encapsulated in a conductive compound, I would say, okay, maybe this would address that. But if the wall itself was still raw metal, that would
Mhm.
still require it.
Yep.
So,
And it's
um,
obviously still within 5 feet. So
yep,
fine.
yeah. So, yeah, when you look at all the different types of pools out there, they can be built in so many different ways with different materials. So the language has got to be broad enough to capture, or try and capture all these different scenarios. I'm sure there's scenarios that we haven't thought of that really should be addressed here.
And
I've heard of, by the way, have you heard of fiberglass rebar, structural rebar? It's not steel structural rebar, it's made of fiberglass. If you looked at it, it looks like a piece of rebar.
yeah, it's got all the little ribs
It
on it. It
is,
looks like a piece of rebar,
but
but
it's
it's not
fiberglass,
fiberglass.
not metal. And folks I've gotten that question too. What if they use that
Well,
in the conductive shell?
then I guess the question for that would be: is it now considered is concrete alone? Well, it does for the brick. I mean, for the block,
Porous,
it's
just like,
poured. It's poured concrete. So I don't know. I think you're just getting away with using the rebar structural steel. It's maybe structural, but I'm thinking this is automatically if it's concrete or whatever. I think it's pushing to the copper grid or the grid underneath it because the concrete is still conductive.
or introduce some steel rebar into, so
How much?
how much?
Much steel rebar.
I don't know the answer to that. And hopefully, I don't know if we'll have to make that decision as a panel next code cycle. We'll see.
Well, the question will be brought up, obviously, about okay, if somebody, because it allows a block, if somebody, again, we can bring up about the fiberglass, but it's the same scenario, whether it's block or whether it's poured concrete without metal rebar, but it's just fiberglass rebar. That's the way it goes. Somebody doing that to get away from it, I'm like, no, all that's going to do is potentially make you have to put a copper grid under the daggone thing, is what I'm thinking.
Maybe.
So, all right. All right, B4, equipotential bonding again, bonding parts of underwater lighting. So all metal forming shells and mounting brackets so you got forming shells and mounting brackets of no niche luminaires shall be bonded. Okay. Exception listed again, low voltage lighting system with a non-metallic forming shell shall not be required to be bonded. Okay.
So that is actually some type of no niche fixture that I was able to track down, but does have a metal forming bracket there. See, so how often these are used, who knows? I was able just to provide it as an example.
So that's a bracket for a no niche. But again, the takeaway here is the metal forming. So the wet niche, although that's still going to have a forming shell, if it's metal, then it's going to be connected. And typically that would all get connected as well inside of, if it is rebar, it'll all be, everything will be connected together. All right, 680.26B5. We're talking now about the bonding of metal fittings and metal structures.
See, yeah, you see the red language here is some
New stuff.
new stuff in the 2026.
So let's see here. So all metal fittings and metal structures within or attached to the pool or perimeter surface indicated in 680.26B2 shall be bonded. Okay. So again, when we talk about B2,
That's all the perimeter.
that's
surface.
all the perimeter. Okay. Oops.
So if we got a metal fitting or metal structure attached to the perimeter surface, this is saying probably going to have to bond it.
Right.
Whatever this fitting or structure is, unless you fall into the exception.
And we've got 4 exceptions here. Right? So this is just a broad statement. All metal fittings and metal structures within or attached to the pool or perimeter surface, even if, like I said, if it's even mounted or installed on the perimeter surface,
Mhm.
okay, shall be bonded. Okay, metal. Except says the following shall not be required to be bonded. Number one, isolated parts that are not over 4 inches in any dimension. Okay, so 4x4. Oh, not over 4 in any dimension, 4 inches. Okay, small piece. And that do not, okay, is the and in there? That's and is an important word because
Mhm.
it doesn't say or,
Right.
right? 4 inches, or if it penetrates. Now, so it is and. So it's any dimension if it's not over 4 inches in any dimension, and do not penetrate into the pool structure more than 1 inch, then that does not have to be bonded.
Correct.
What examples we may have of that might be, um, I guess you could have some portions of a luminaire. I guess you could have is there some portions of maybe a luminaire's trim or something that isolated? It's not more than 4 inches in any direction. No, that wouldn't work because that's going to be down. That's going to be down 18 inches, right? Or
Mhm.
down deeper than that, right? So what we'll be talking about that did not penetrate more than 1 inch. Let's see. I can't think of I'm not thinking of anything. You know what it could be? You could have like the netting or what is that thing you don't cross from the deep to the shallow? You could have some metal loops
Oh,
in there
actually, in the pool,
in the pool.
yeah,
Okay,
they have.
they're in there near the top. They're not more than they're not penetrate into the pool. Maybe structure more than 1 inch. I think these probably do. Probably go down a little deeper than that. But again, it's just saying again, we don't know what it was. I mean, what could be there, but any isolated part that's not more than 4 inches in any direction, and it does not penetrate into the pool structure, not necessarily the water, into the pool structure more than 1 inch. That's the case. Dimensions and how far it can go down into the pool. Don't have to bond it. Don't have to do anything with it. Not enough area to be a big issue. Number two on this is metallic pool cover anchors intended for insertion in a concrete or masonry deck surface, as long as they are 1 inch or less in any dimension and 2 inches or less in length. Okay, so 1 inch in any dimension, but the overall length of the anchor that goes down into the decking is what? Less than 2 inches, right? But the length is 2 inches or less, and the overall surface area. And I think one of the things that I think about this is the deck anchors, is that they may have a flange on it, so they may have a loop, right? And it may have a loop with like a trim around it, a perimeter or a round deck or whatever it is that the loop connects to. But the anchor portion can't be more than 2 inches. So it's 2 inches or less in length, the anchor portion, right? Which is still 2 inches is pretty good down in the
Substantial.
decking. So it's going to go down pretty good for the cover. And then it's the area above where the loop would be, or maybe the perimeter flange or whatever, as long as that one there is what? Is 1 inch or less in any dimension. Well, it's probably not. It's probably going to be 1 inch. Exactly. So anywhere across it would be 1 inch. Then have a nice little loop on it, and that's what you would, connect the pool cover to, that type of thing, or the spring tension it
Right.
connects to it. So that's probably what you're getting away with there. Next, it says, okay, now again, that's conductive surface, right? That's concrete or masonry surface. Next, we have the third one, and this one is okay, same thing, anchors intended to insert in wood or composite decking 2 inches or less in any flange dimension and 2 inches less in length. So this one you get a little bigger, a little more, right? But the length of it is still 2 inches or less. Going down into. So that type of thing. So those things, guess what? And why is that so important? Vince, could you just imagine somebody coming along, an inspector coming along, and you had these anchors all the way around the pool, and he wants you to go from anchor to anchor to anchor? I mean, really? I mean, I couldn't imagine, but I can bet you somewhere out there somebody said, "Oh, that's a metal part within 5 feet
Well, without the
connected."
exceptions, it is a metal part
It
within
is
5 foot. So, you have to,
metal fitting,
a literal reading without the exception language would have said, have to bond them.
and it's in the perimeter surface.
Yeah, it's in front of the surface. So this language relaxes that. So that should,
And this isn't new. This has been around.
that's
So,
right.
so that's not necessarily new information. It's been around. Number 4, metal fittings and metal fixed parts in bulkhead construction of non-conductive materials within the pool with no conductive connection to the pool or perimeter surface indicated in 680.26b2 by the bulkhead and or metal parts fixed to a bulkhead.
So I don't know about you. When I first saw this public input come in talking about bulkheads, I had no idea what a bulkhead was. I'd never heard that term used associated with a pool. So I really had to,
Separation of different sections of the pool,
yeah,
right?
but I had to go look, I had to go Google,
Look it
and
up.
I said, I got the PIs in, they come to us as panel members, and we start looking at them individually. Bulkhead.
Hell is
What
a
is
bulkhead.
this? I just Google and find out
But it's
exactly.
important because you know what? It's not a deck. It's not a
Right.
perimeter surface. It could be concrete going across it, separating. I think you have a picture of it in
Yeah,
your
so
presentation.
pictures help and see what
So
they
here you
are,
go.
right? Yeah. So
Here,
first,
stay off the bulkhead.
I guess we'll go back to those anchors. Those are
Yep, there
the
you
picture
go.
on the right. Examples of those anchors that probably all these anchors meet the dimensions and the exceptions. So no need to go and equipotentially bond those.
Now, what's
They
the
stay
point?
below. But then the last new exception is dealing with this bulkhead language. So, and to your point, that's what these things are. In these larger, you know, very much larger pools, there are these floating structures in there to set different distances and bigger Olympic-sized swimming
Yeah.
pools. Where these are movable. To
Yep.
go
Yep.
with this.
You can see it down. I don't know if I back up a little bit. You can see there's kind of a
A
track right
runs
here. Right.
but so, but they're non-conductive.
Yeah.
But they do have, right, obviously some metal parts and pieces.
Yeah. Here you see right here in the middle, there's looks like a metal pole right here that holds the flagging. Here you see the metal flanges for the
Right.
for the poles so they can move these down, whether they're, however they want to do the ribbons or whatever, that type of thing. So again, you got some metal parts. You got this rail right here.
Correct. So this is, again, if we look at the language, what's the exception saying again?
Okay, so looking at the code, it says metal fittings and metal parts fixed to bulkheads constructed of non-conductive material. So the bulkhead is non-conductive material within the pool with no conductive connection to the pool or perimeter surface. Again, so it's floating.
Right.
It's on a track. Okay. So then if that's the case, then it's saying that by the bulkhead and or metal parts fixed to the bulkhead. So I'm thinking you don't have to try to get anything out there on that bulkhead.
Correct.
It's
Because
movable.
and the bulkhead is non-conductive. So all those metal parts and pieces we saw, that handrail going around it and the metal poles, which normally if they were attached to a perimeter surface, probably say, well, they're going to have to require equipotential bonding. But no, this is saying they're on floating on this non-conductive bulkhead. Bulkhead's non-conductive.
They're not even in the perimeter
Right.
surface
It's not
because this
really
thing is
any
inside
conductive.
of the edge of the pool.
Right. So nothing has to be done to that bulkhead. There's no equipotential bonding requirements to connect those metal parts.
Another example of a nightmare if somebody were to come up and say, oh, now, how did this become a movable thing if now I've got to have bonding to all of this stuff?
Yeah. And
I'm
this
going to invent a product. So here's how I'm going to invent a product, folks. Watch my mouse here. I'm going to invent a product while I'm here. I love to invent products. In this track system, this is going to be kind of a metal grid that's obviously going to be bonded, right? But although it's not in the perimeter, but it's metal, it's within 5 feet. Either way, it's in 5 feet. Okay. Now, as it's you bonded here, the rollers on here are metal or have metal components, or at least a portion of it's metal, so it's always in contact. So maybe just one of the tracks is metal. It has an internal bonding component that runs all the way down inside of this plastic that these all connect into. So as you're moving it up or down, it's always connected to the metal portion of a track. And maybe it's only the metal is the end of something. It's kind of think like a sprocket, where this end is metal and it goes down into a recessed portion of this track. That becomes metal to metal contact, goes up into the sprocket, up into the bulkhead, and then connects and runs down and connects to all those metal parts.
But the good news is
Don't have to worry
you don't have
about
to
it.
do it because the exception says don't worry.
Oh,
As long as the bulkhead is non-conductive. And
yep. And that looks
I-
like a plastic one
you
or
know,
something.
I don't know enough about these. I guess we could always go and say,
Well, that
are
would
the
have to
ones
be
that
it.
are conductive bulkheads? And
You think there
I hope-
is?
I hope
Because
not.
I'm thinking it's got to float, so it can't be concrete. It can't be, it's got to be floating. These things probably hollow uh, at some point. The type of thing.
You
I
would think so.
they give you a sign saying don't attempt to swim under it. That type of thing. So it goes down in there pretty good. It probably, if you look at these holes here, if I go back, it might flood it with water, and that's what helps weigh it down or something.
Mhm.
I don't know. But good news is we ain't got to worry about it.
Yeah. So
What do you think they did before we had this language in the code? Do you think there's an inspector out there that said, I guess if it's still within 5 feet, it's just on the other side of of what we usually think about. This is over in the pool area, 5 foot. Okay.
as we're talking, I'm looking for a picture, see if they actually make a metal. And guess what? I'm
They
finding pictures of stainless steel.
stainless steel bulkheads.
So I and as
Well,
I'm saying that,
this one only addresses a non-conductive
right.
one made of non-conductive material.
So I don't think we have to go down this rabbit hole, but does that conductive bulkhead require equipotential bonding? It's metal within 5 foot.
And there might already be a track system that I'm
That
talking
takes
about
care of that.
that takes care of that. But I would think if it's within 5 feet, let's not forget that the 5 feet necessarily is a one-way street.
3 foot out
Yeah, I mean, when we think anything within 5 feet,
doesn't
okay,
go into the pool.
yeah, I'm thinking the within 5 feet is the language going to say that is only
But it's metal within
Yeah.
5 foot.
yeah. If it's a stainless steel bulkhead, it's obviously going to be within
Right.
5 feet. Whereas this one is a non-conductive. They don't care about that rail. We don't care about that type of things. And I never would have thought they would have had a stainless steel version to that. But
The things you learn.
you learn. Or maybe things we don't want to learn, don't want to gain.
Yeah.
All right, next. So 680.26b6, again, this is bonding parts of electrical equipment. So metal parts of the following equipment shall be bonded: electrical powered pool covers, pool water circulation, treatment, heating, cooling, and dehumidification equipment. And number 3, unless separated from the pool by a permanent barrier that prevents contact by a person, any other electrical equipment within 5 feet measured horizontally from the inside wall of the pool, or 12 feet measured vertically from the maximum water level of the pool, or as measured vertically above any observation stand, tower, or platform, or any diving structure. So this would be, let's go to the code. I gotta feel like I gotta see the code.
Let's see the language.
Let's see what we're here. Okay. So again, before we get to the 5 feet, it's flat out saying electrical power pool covers got to be bonded,
Have to be equipotentially.
potentially bonded. Good. Number 2, pool water circulation, treatment, heating, cooling, and dehumidification equipment, regardless of where that pump motor or circulation is located.
Right.
It's
Anything where
gotta be
water
connected.
is circulating through this particular piece of equipment, right?
Gotta
Heating,
be connected.
cooling, we're gonna have to take care of that equity. Yes.
Okay.
And then
And
got
then,
some wordy language here.
yeah, unless it's separated from the pool by a permanent barrier,
So
then it's saying, okay, if that's the case,
any other electrical equipment within
Right.
5 foot measured horizontally.
from the inside wall of the pool, right? So does from the inside wall, does that necessarily mean that it always has to go out or can it go in?
Sidewall.
Measure from the inside. So could I measure inside this way or that way? I could go either way. I don't think we ever think about that. And now that you've got this steel bulkhead in my damn head,
It's metal within 5 foot.
it's metal within 5 feet. So, yeah. So anyway, so yep, the language is there, and so all of that makes sense. So we got all those requirements. So the other thing, I guess, is you have a picture, and you're down in Florida. So this, what is these, a lanai? Is that what they call them? What is this? These screened in porches area? Is it called a lanai?
Yeah.
Is that what it's on?
Yeah, they call them a lot. Sometimes there's sunroom, some type of sunroom.
So if
but-
this is metal, all these frames are metal.
Yep, show your cursors.
Oh,
Again, you're
keeps
pointing
disappearing right here.
Pointing that. We're going to say those are metal door
All
frames.
this is metal.
So it's metal within 5 feet.
Feet.
Cool.
Yep.
So
Got to be bonded.
it's going to have to be an attachment to that frame.
So-
And really one attachment, one of those pieces, since they all look like they're interconnected.
Well, whoa.
Whoa.
What about that steel reinforced that's all bolted together? We asked whether or not we had to do one piece or you had to bring to all of them.
Mhm.
But yet here in a lanai, it's all still bolted together. And we're saying we really only have to bring it to one piece.
I think so. My inclination is yes, and my inclination's on that steel frame.
That it's one
almost
location.
shot and you're done. But
There you go. But have you experienced any of them with the lanai like this within 5 feet that they would be bonded?
yes,
I personally think they're probably just going to go and they're going to drill and tap it using 250.8 and put a lug on it and bring a lug up to it and just and connect it to one location.
that's what I
Well,
did
that-
back in my contractor days. I mean, I had to do this because I did a lot of pools that were installed later. You know, the existing home was there. It was there for years, and they added the pool and was within 5 foot of metal windows and door frames. I made one attachment,
That's it.
and I never
Think of the
was questioned.
nightmare thinking you'd have to do each piece of that panelized. That's probably a panel. No way. It's not practical to do it. If they're all bolted together, it's all together. It's all as one.
Yeah.
So
The bigger problem was the homeowner who just paid, 50 grand for this beautiful pool. And then you look over in the corner and there's an 8-gauge wire running up the side of their house to a lug attached to a door frame and, ruining the whole ambiance of,
the look of everything. you know?
of their $50,000 pool. That was tougher to maneuver than, AHJ's.
Now, when we were just talking about motors, okay, say for the pump circulating the water circulation of pump motor, we have an exception here. Okay, metal parts of listed equipment incorporating an approved system of double insulation shall not be bonded. Okay, the best one I can think of, if for my example, would be a pool circulating pump motor, where you could get a double insulated pool pump motor,
Mhm.
right? So let's use that as an example. I'm sure there's other equipment that may do this, but let's just I guess it could be what, electrically powered pool cover, typically a motor.
So maybe you could
Maybe
double
you can get one
insulated.
that's double insulated at that point. And again, that's going to be an exception to this rule where you don't have to find an electrically powered pool cover. But there might be other metal elements of that pool cover that would not be the motor. The motor might be remote and separate than where the mechanism is that moves the pool.
That's true.
So that metal would be within 5 feet. That still would have to be bonded. So in this one, we're talking about the listed equipment that's incorporating an approved double insulated system. So we're going to use motor for simplicity's sake to be able to talk about it. And so that's going to bring us here to 680.26B6A. Okay. Now, again, different from the other because the other one was general. Any listed electrical equipment incorporated that system. But that's why I've kind of moved off of that exception, which could have applied to the pool cover, could have applied to other types of things within that area, right? Moving on to something that we talked about earlier, I think it was in part one,
Mhm.
is okay, well, what happens if I have a double insulated water pump motor, circulating pump motor. What do I need to do? Okay. Well, we already know we've got to bond it, right? We saw that earlier. It's required. There's no way around it. We're going to have to do that. It's right here. Okay. Pool water circulation. We're gonna be taking it over to that. We got to bond to this motor. Okay. So what are we going to be doing? Remember earlier, we're going to be running an 8 gauge. We're going to run it over to this motor, right? All right. So we get over to this motor, and this motor happens to be a double insulated water pump motor. I want people to get into their mind that it doesn't matter. I need you to go on and run that 8 gauge over to it. Just run it there. At some point, they may replace that double insulated water pump motor with a non-double insulated, a regular one, right?
Right.
It's going to have a lug on there for you to be making connection for the equipotential bond. It's going to be there, right? At some point. So here's what it says. Where a double insulated water pump motor is installed under the provisions of this rule, a solid 8 AWG copper conductor of sufficient length to make a bonding connection to a replacement motor. Again, if you replace a double insulated and the one that you replace it with just happens to be one that is not double insulated, right? So it's got to make sure that I run that 8 over there. It's got to be sufficient length to do so. To connect to a replacement motor shall be extended from the swimming pool. Equipotential bonding means to an accessible point in the vicinity of the pool pump motor, probably typically right over next to it, near it.
Yeah. So folks, we just have to run the 8 gauge over there, leave a loop of some length that makes everybody happy. Just leave it sitting there waiting to.
Now we know that it has to be pretty damn close because the next step will say where no connection between the swimming pool equipotential bonding means and the equipment grounding system for the premise, then this bonding conductor shall be connected to the EGC of the motor circuit. Okay. I think the key element here is says where there is no connection between the swimming pool equipotential bonding means and the equipment grounding system. There is probably without a doubt other applications. If you have other motors or other applications in here, that's going to have an equipment grounding conductor that is going to be connected at some point through some piece of equipment to the equipotential bonding grid through some type of equipment.
Yeah. So I would say, if you have a swimming pool light, a luminaire installed inside this pool,
Yep.
you've probably done some equipotential. You may have done equipotential bonding to the wet niche,
which is going to have an equipment
which
ground.
makes the connections to the equipment ground. So that's taken care of.
Yeah.
So you would not, for this application, you would not have to make this connection. But if there is no other connection somewhere,
you have a pool that has no other potential connection to an equipment grounding system anywhere,
you're going to have to make a connection. And honestly, I don't know how you would physically make that happen. How you would connect this 8 gauge to the equipment grounding conductor inside this motor.
It's hard because the motor goes into a head that's into the motor. No room in there to do this.
Not for an 8 gauge, man.
So
it's really tight. So
I think you're probably going to have to come up to some other junction box. You're probably going to have to make it long enough to get up to maybe the switch or the disconnect or something that would be the equipment ground that is part of that circuit.
Mm-hmm.
I would think that was something you would have to do.
Yeah. The way they would come. Yeah. So,
but I think that there's a vast majority of the problem probably going to have some other connection through lighting or something else. Now, you could have the low voltage contact limit type of lighting that has no ground. That's not going to work. Lighting's not going to work at that point. So you have to look at your installation. But again, this is how you achieve it. It's going to be different everywhere else, but you're not going to do it in that motor. You ain't no way you're getting that solid 8 inside of that motor head. That ain't happening. So
made a little ingenious, maybe.
Yeah. Figure out.
We're good at that as electricians. We can find ways to make
ways. Maybe the key takeaway here is that it does have to be connected to the EGC for that motor circuit. You're gonna have to find a way to do it. Look at your install. Is it easy? No. Remember what the code said. Not everything that the code tells you to do is going to be convenient.
That's right.
Okay.
That's 90. whatever language, 90.2, 3, 4,
90.2,
somewhere in there.
Look, code is the code. It's not always efficient. It's not always the cheapest way. It's not, so again, you got to do what you got to do to make it happen. Again, we can gripe about it, but it is what it is. The next one, and I think you got covered as well, is the pool water heater. So it says a pool water heater, and again, this is a pool water heater rated at more than 50 amperes and having specific instructions regarding bonding and grounding. Only those parts designated to be bonded shall be bonded, and only those parts designated to be grounded shall be grounded.
I don't. That's kind of legacy language. I think it's been here for as long as I can remember. I don't really know the history about it or why there's such a specific language associated. So, I mean, pool water heaters, it's pool equipment. It's required to be listed. These things come with lugs from the manufacturer as part of the listing. Make the attachment like you would to the pool pump motor that comes with the lug.
I think the key crux to this is, unlike with the pool pump motor where you have to make a connection. Here it says, look, if it's within 5 feet and there's a bonding lug on it, and you're taking the equipotential bonding, you're taking the jumper over to it, that's it. You just go to the frame. That's it. That's the bonding. The other aspect of it, the grounding, like say through an equipment grounding conductor, that's going to be its function, and that's part of the equipment that runs into the equipment. That's going to make connection into the equipment. Keep them separate when it comes to the pool water heaters. I think that's the key thing is do what you need to do for the bonding. If it's within 5 feet, do what you got to do, or that type of thing, and be done with it. Now with this one, I guess the 5 feet doesn't matter. 5 feet doesn't matter because this is part of heating. So regardless if you have a pool water heater, you're going to have to bond it if it's metal, right? Because that's the only thing you wouldn't bond it if it wasn't metal, right? Because I think if you look at the language that we looked at the code up here, right here, pool circulating, treatment, heating.
Yep.
Right. So again, this is not about the 5 feet. This is just flat out period.
That's correct. Yeah, and I would assume there's some kind of history with the amperage threshold.
Yeah, the 50 amps.
50 amps. I just don't know the history of it. So look, this is very specific to a heater. Rated more than 50 amps for some reason. Maybe it's because the loads have to be subdivided. So kind of language with that separate. Maybe that's something to do with it. But I think the reality of it is, look, the manufacturer is going to give you a lug, maybe 2 lugs. I don't know on some of these.
Yeah, I think you take the
attachments.
I think you take your brand circuit to it, and you're going to get in there. You're going to get an application where you make your connections for your equipment ground.
Yep.
Done. I think if it's metal outside, you're going to get a lug, and in this situation, it's doesn't matter if it's within 5 feet. You're going to run you're going to extend that connection over from the equipotential bonding grid. You're going to connect over to it.
And that's it.
And
Move on.
Keep them separate and move on.
Yep.
All right, 680.26B7. Now we're talking about fixed metal parts. So this is the doozy one right here. This is what turns a pretty installation into a potential nasty installation.
Right. So yeah, if something hasn't been captured already in the 6 list items we looked at,
right,
this is going to capture it. But remember, this is fixed metal parts. These parts have to be fixed. They're not fixed to something. They're quote unquote movable. Like a metal lawn chair. No, we're not concerned about that.
Not worried about that.
But if it's some kind of fixed metal part, then it's going to fall in here.
All right. So it says all fixed metal parts, including but not limited to. So it's again, we're not giving you an all-inclusive list here.
Right.
Metal sheath cables, again, would be like an MC, but it's PVC jacketed, let's say, would be example. But it is still metal sheath, regardless of the covering on it. Still, if that was near it, although I don't want nobody cutting into no PVC trying to, no, don't do that. And raceways, so any metal raceway that may be near it. Metal piping doesn't necessarily have to be for electrical conductors.
That's correct.
Right? Whatever metal piping it may be. Metal awnings. Oh man, Just imagine going up and trying to connect to a metal awning. Okay, but we're gonna have distances, so maybe we can fall outside of the distances.
Let's
Let's
hope
see.
so.
Metal fences. Here you see a picture of the fence over here. Okay, that's obviously within 5 feet. Say, looks like that's within. Metal doors and window frames. Yes, can turn a nasty installation quickly. Shall be bonded where located not greater than the following. So, if it is 5 feet horizontal from the inside wall of the pool, so 5 feet or less,
Gonna have to bond.
we're gonna have to
Some
bond it.
potential bonding.
Any of these, and again, not limited to, right? Not limited to. Okay, so again, it could be some other metal fixed part that's near there. Okay, one of the things you don't see here, I guess, in this list is what about metal gutters, Vince, downspouts?
It's
metal,
metal within 5 foot. It's
5
fixed.
feet. It's fixed to the side of the structure. You're gonna bond to it. That type of thing.
Yeah, or move it.
Yeah, or move it,
Get it
reroute it somewhere else.
Get a 5 foot one away, and then you
Don't have to deal with it. Number 2 is 12 feet. So that's the horizontal. 12 feet vertically above the maximum water level of the pool, observation stand, towers, or platforms, or any diving structure. Okay, so
so it's
any
with,
metal parts,
that means if it's within 12,
okay,
right? So it would have to
yeah,
be
anything up to 12 feet.
right when you hit 12 foot one. Good, you
You're
don't have
good.
to worry.
And again, it's from the maximum water level. Okay. An exception, it says those separated from the pool by permanent barrier that prevent contact by a person shall not be required to be bonded.
Right, and
So-
we've seen that language before.
Yeah.
This permanent barrier language. Sometimes there's a 5 foot associated with it. We've seen relaxation of some requirements if that's present.
So don't anybody out there get the clever idea to say that this fence in this top picture right here, right here, is considered a permanent barrier. If it was metal, it's still metal and it's within 5 feet.
That's
Okay?
correct. Yep. I would say ignore that picture, that
That-
bottom
that's
picture.
an
That
ex-
has nothing to do with
That has
this
nothing to do with
requirement.
this one
It's
right here. But for
for the
those that want to
variance
know
of
what that is, that's for going into a skimmer or for actually bonding the water
Mhm.
under C, which we will see, I think.
Yep.
All right, so here's an example fixed. There you go. That's nice. Out there is your metal frame right there, right? Here, this and this. And again, so this slide right here is, again, part of another slide deck, but we appreciate this for fair use practices. So we're just kind of looking at an example. This gives you a good example. Here's your fence. All right, more practical. Look at that. Right up into that. I mean, dude, you like going right up into it. There's some gutters,
Yeah. So these are
metal frames. maybe.
problem child installation, right? Because
Real?
it seems like there's an awful lot of fixed metal parts within the 5 foot, 12 foot dimensions.
Yeah.
So yeah, these can become really problematic. But we have the language, like you said, the language is the language that we have in here.
All right. So we're out of that. So fairly painless from that part, right? I would say 2 hours and 57 minutes into dot 26 alone.
And we're at the end here though of this equipotential bonding. I think
Yes.
this is the last
This
requirement.
is the
dealing
last
with the
requirement.
water.
This one. And it is bonding of the water. And so where none of the bonding parts in B1 through B7, that would be things like ladders, steps. You could use the probably maybe a luminaires trim that was metal that's connected to the equipotential bonding grid, all that. So again, so where none of those things are in the water, you still have to bond the water. And people say, well, how the hell do you connect to water? Well, you
same
got
way
all
as
these
we
things that
connect.
are in the water.
Right? Same way, how do we connect to the earth? Oh, we have to jam something in the earth and connect to it. Well, how do we bond the water? We're gonna have to put something in
You like this
contact with the
theory here. You keep, what did you say for the other thing? Was in the earth? You're like,
You gotta jam something
gotta
in there.
jam something in. Okay.
Whatever that something is, like a ground rod.
Rod,
If we're
pipes,
doing a
plates,
250
concrete
application.
based electrodes.
So we're
ground
dealing with
rings.
equipotential bonding and perimeter surfaces. Well, we got to jam a piece of rebar, the copper mesh, wire reinforcement. So, and
Got it.
here now we're dealing with the water. Well, you can't take a lug,
And
attach
connect
one
it
end
to
of a
water.
number 8 to it, and throw it in the water. Right? We have to jam something in contact with the water pumps to make this.
Now, in all fairness, if you have, and they're probably less popular than they would be, is metal ladders that are going out of the pool. A lot of them now are metal, but they're either covering or they have some kind of PVC coating on them or something on them. That wouldn't qualify. It's not in contact with the water. Yeah, you may get that surface area based on, let's say, in the water. You may have a drain that has an actual metal cover on the drain
Right.
that gets bonded. It's a metal part. It's in the pool. It's part of all that bonding that's going on. That may give you enough surface area. So, how much surface area is necessary
So let's
to do
let's
this?
back up one step though, before we
Okay.
get into this. If I've got a conductive pool shell, someone's dug the hole with a bunch of steel in there,
Oh, I know where
and
you're going. I know where
and
you're going.
right, gunite this or concreted or whatever the
The
term is
rebar's
used,
in it.
right? And we've already connected that conductive shell to the perimeter surface to all this other things that may be in the list items. I
Done.
do not have to deal with this requirement of bonding water.
It's
It's
done.
already taken care of because
B1.
B1, and it says if something is not in the B1 through 7 list items, then I got to deal with bonding. So just the takeaway so far, you got the conductive shell,
Done.
you already bonded it for B1, you've already accomplished the
It's
bonding
the
of the water,
It's the
right?
trust me, it is way more than 9 square inches if you have a conductive pool shell.
Right.
What's the point? I have had inspectors say, "Oh, I need you to now bond the water," and you got to look at them and go, "Wait a minute. If this is rebar and concrete, this whole freaking thing is connected to the water."
And that's just that's a misapplication of requirements. This really applies to probably a fiberglass pool.
A
We,
vinyl pool,
we saw that
liner.
metal skin pool where they're going to drop the vinyl liner in.
Yep.
It may apply there if, right,
But it'll apply because that metal's not going to be touching the water.
right. So this applies if there's not something else that exposes 9 square inches. So if I have the fiberglass pool or that metal skin pool where they drop the vinyl liner in, but there's a metal handrail that's in contact with the water, well, that metal handrail is going to, in the list items, is required to be bonded. The
Right.
handrails are usually bonded in the cups that they sit
Yep,
in.
with a cup. Yeah.
So as long as there's more than 9 square inches of metal handrail in contact with the water, if there is, that accomplishes this requirement.
Yeah.
Correct?
Yes,
So you don't
sir.
have to bond the pool water. If
Correct.
you've got a wet niche light fixture with a metal frame,
Yeah.
that
Which
accomplishes
all
the
has
bonding
to
of
be
the
bonded
water,
back
right?
to part of the grid. It's all bonded, the wet niche, everything, whatever it is, it all has to be bonded. Done.
It's done. So this is saying again, where none of the things in the list items are there. All those list items that we went through, the B1 through, none of that's there.
So
And we've got this non-conductive pool shell, most likely, or a vinyl liner. And now we're going to have to expose 9 square inches of metal to it and bond that 9.
and one way to do that, again, if we have a fiberglass pool and maybe the rail going into it's fiberglass, maybe the ladders fiberglass or plastic, there's no contact with the water. And you're right, we got to bond the water, right? And so in doing so, you have some options. This is just some options here. This actually goes in a skimmer.
Yep. Bring your mouse up.
Oh, just appeared. There you go. So this goes in Skinner, and you can connect the connection here, right? This goes around contour of the round skimmer. This one right here, I don't know exactly how this one mounts. I don't know if this is a copper
Yeah, so
conductor here.
it is. That actually is that threads into a plumbing T. The T is cut in to the plumbing lines.
Oh, this will thread right in it, and it has enough surface area
right. Looking at
to
that
do it.
picture, that piece to the right
Yeah,
of
right
it,
here,
to the right of the threads.
right here.
Now the chunk that is 9 square inches of surface area that
In the
would be
circulation
down
of water.
in contact with the water. Yes. The only thing is haven't dealt with this as an AHJ. All these, anything you introduce here, like the piece in the skimmer or that piece that threads into the T, has to be listed for this application, and you'd have to follow the manufacturer's installation instructions like we talked about. So with that one that threads into the T, when you look at the installation instructions, manufacturer basically says it has to be installed below the normal water level of the pool.
Hmm.
So it actually has to go underground in the plumbing system. Then the manufacturer also says you really need to leave access box to
To get to
access
it.
it, because the 8 gauge is the technology of it is you attach the 8 gauge to the stem of that fitting.
Is it like a
the
split bolt? Like, okay, it's like
So
split bolt.
it's not a permanent connection. So you always have to have access to it. That always has to be in a piece of the
That
plumbing
sounds
has
like a
water
pain in the
inside.
butt. I do know they also make some that are designed that you can put in cut the piping if it's plastic piping. You actually can interpose it into the water line, and it has inside of it enough surface area. And
Yeah, as long as it's a listed product
Yep.
designed to do that.
Yep.
Again, it's all per the installation instructions.
And so, ending this one out, it just reminds us that if you do need to use something like this, okay, or at any rate, you need to have a direct contact with the pool water. The pool water shall be in direct contact with the approved corrosive resistant conductive surface that exposes not less than 9 square inches of surface area to the pool water at all times. And I think that's the point you made, at all times.
It has to be in contact with the water. Yeah, and that becomes honestly tricky. I had some installations. I was, I had to ask a lot of questions. That fitting was cut into the plumbing line. Question always was,
Is there water
is there
always in it?
always water? Depending on, even when the water's not circulating at night, shut off at night.
Right.
Sometimes folks you have to move a handle to vacuum the pool.
Mhm.
Turn a valve. Sometimes there's suction or backwashing of pools. The valve gets turned. So my question always was, well, where you just install that, is that piece of the plumbing pipe or that piece of the plumbing system for the pool, does it always have water there
Right.
in any application? Not running, backwashing, vacuuming.
Not just
Is
when
it
it's circulating. When it's just sitting there, is it going to be in contact at all the time?
at all times? So, and I always got the answer of yes, obviously.
Sure it will be.
And hopefully that was the correct answer.
And
Yeah, just be careful with it.
also, this surface shall be located where it is not exposed to physical damage or dislodgement during usual pool activities. I think that this actually, I don't know if this mounts through the side of the skimmer and bolts onto it, and this stays in the skimmer portion.
Yes. Yeah, it's kind of a back plate to the skimmer to expose that surface area.
So I will say with these, you better be prepared for that, because if it's just a normal skimmer and it's not designed for this or doesn't have you're going to have to drill it. You're going to
You're
have
in
to
trouble.
you're going to have to put it in there or find another
Do something
method.
else.
All right. Well, there we go. So here's a good example of the rail.
Yeah, so that's a fiberglass pool.
Yep. There's your.
But it looks like that handrail goes down into the water, and hopefully it does. And hopefully there's enough surface area of that metal. And if that's the case, you're done. No requirement to go do anything else.
Don't have to do anything else. Well, I'm sure we have another picture of that pool. There you go, right there.
Yep, and hopefully that handrail.
There you go. It's in the water.
So we should be
done.
Good to go there.
Nothing else. Don't have to do anything else. Don't let somebody tell you now you've got to go and try to bond the water. It's done right here. As long as this rail is connected to the Equipotential Bonding grid, and it should be.
And it's required to.
Yeah. So we shouldn't have any problem with that. Okay. All right. Do we have any more? Let's see. Okay. Let's see if maybe there's an example where you would have to do it. Okay. So here's one.
Let's see what I put in there.
All right.
Yeah,
that's not going into the water.
That's not.
This looks like a fiberglass drop-in, smaller one.
Yeah, I see. Maybe there's
Plastic
some aluminum.
jets.
Well, those are the jets to circulate the
Plastic
water.
jets, smaller one, circulate the water. So here, we're gonna have to bond the pool water.
Yeah, something's going to have to happen. Hopefully something did happen. Take care of that.
Right. Oh, don't want to go there. All right, folks. Fairly long one. Paul was wrong as usual when it comes to how long it would take to get through the equipotential bonding. There's a high probability, folks, that this will actually be as part of the series, but this will be also a standalone one for equipotential bonding for those that may have a good grasp of everything else and they just want to see what's taking place for the 2026 when it comes to the equipotential bonding. So it'd be a good video that people can pull out and do that. And so in the next video, anything else you want to add, Vince, on this?
I think we went down
Every rabbit hole we could
went
go.
down, we covered that in pretty good detail, hopefully not making it more confusing. So we provided some guidance about what the language is trying to tell us.
Absolutely. And so, folks, we're going to, in the next video, we will continue on with 680.27, and we're going to end up part 2, and we're going to keep on going through this process. We'll see you in the next video.